What up? What up? Welcome back to another episode of Large Data Bank. Happy Friday, y'all. It's good to see you. It's been a minute. It's been about a week, as normal. It's usually about the length of a minute when I say a minute at the beginning of the stream. What is up? Hydron, Drunk Time, Null Bitmap, Lithium, and Dirter. Crypto Code. Good to see you too. It's been a week, y'all. It's been an absolute week. Saf Affy, hello to you as well. It's been an absolute week of excitement, drama, watching The Boys on Amazon Prime, tennis, working, all right? Some good stuff, some definitely good stuff. Maybe a little bit of, do I have COVID? That's a question. That's a potential question on the negative side. Open question, do I have COVID? Could be not. Don't feel sick, but I was hanging out with a COVID positive person recently, as it turns out. But it's been a week, you guys. It's absolutely been a week. Really, the most thing that's on my mind is how... So we worked together. No, it was not. It was not. Don't you worry about that. Don't you worry about that null bitmap. Not related to that person. It was my fiance's sister who came to hang out with us and play tennis. And she may have COVID and maybe I have it now too, but hopefully not. I'm setting an intention and the intention says I don't have COVID. So that usually, that like goes well, right? Like normally if you just think you don't have COVID, then like you probably won't. MD Layer, what is up? It's been a long time. Nice to see you. Thank you for the 27 months. Jeez Louise, that's a lot of months. We're getting up there. We're getting up there. I'm doing great, actually. I'm doing great. I have no symptoms. It's just like it's a fear in my mind. I'm like, maybe I have COVID now. That's basically what I'm thinking. But you know, so far, so good. All good. No problems, no problems, no problems. What's up, Chachi? Do I watch any tennis? I actually don't really watch any tennis. I'm just trying to learn tennis, like as a very basic baby beginner tennis player. Just trying to hit that ball over that net, you know, in a way that the other person can hit it back and kind of go back and forth, you know, rally, have a good time. That's my goal right now. Be able to hit the ball back and forth for a little while. That's the goal. No competitive, no this, no that, you know, just chilling. Just chilling. Test day 3, day 5. So far negative. We're at day 3 negative. So I think we're probably going to be fine, but we'll see. We'll see. What's up, Rob White? You had COVID a few weeks ago? Darn, I'm sorry to hear that. Tired and slept more, full recovery. Yep. I had it like 9 months ago, back in February or January, and it definitely sucked, but fingers crossed. We're chilling. We're not getting COVID. What's up, Rohan? Did I try upper arm serve yet? I don't know. What's an upper arm serve? Is that like a special serve, or is that just like the ordinary, like the kind of thing that you do, just like an ordinary tennis serve with the whole, you know, pronation stuff? I played a little tennis in high school, so I learned a little bit of that. I don't really remember how to play, and serving a tennis ball is quite difficult. But you know, we're working on it. We're working on it. Backhand to backhand, back end. From backhand to backhand. Boom. Boom. That is a joke. I love that joke. Yeah, that's what happens when you hit that tennis ball. You get a like a boom, you know? So listen to this though. I started watching. All right. So listen, here's the thing with tennis. It's a hobby that you cannot necessarily burn out on as easily as other hobbies. I don't know about you guys, but I'm an absolute serial hobby burn-outer because I find something that I love and I just like eat it up. You know, I'm just like doing it all the time, thinking about it all the time, just consuming that hobby until I get out the other end and I'm burnt out and I don't ever want to do it again. So far, it seems like with tennis has a natural back pressure mechanism built into it. At least playing in New York City where I live, because it's quite difficult. You have to like reserve a court ahead of time, right? And these courts here get reserved up because people want to play tennis. which means that you can't just go spontaneously doing it. You can't just like do it a million times. You have to like be intentional and have a partner and like plan it out and like do this and do that. So it's like it's sort of slow going. You have to, yeah. So you can't eat it up so fast. That being said, truthfully, I need more. My friend was like, you know what you would like, Jordan? The tennis anime. So I watched a couple of episodes of the tennis anime called Prince of Tennis, and goddamn, that is a fun anime. I recommend it. I don't know if I'm going to watch the whole thing, but it was really entertaining for the first couple of episodes. The real show that I'm watching right now, though, is The Boys. And people have been recommending me The Boys. I don't really like superhero stuff too much, but people have been like, watch The Boys, watch The Boys. And I started watching it. I was like, this is really bad. It's like kind of cringe. It's not that funny. It's very stereotypy. And I was like, okay, it's sort of entertaining, but it's bad, you know? But I started liking it. My current stance is that after having watched one season, I think it's a bad show, but it's a funny show and an entertaining show. So it's one of these things where it's like, I like it, but I think it's bad, but I like it. I don't know if anyone else is watching The Boys, but that's kind of my take on it. Sports animes are the best. Volleyball anime, I haven't watched that. What about the Go anime? That's a good one. Just have a tennis court here at the house. Wow. Okay, Lithium. Big flex. Just has a tennis court at your house. Okay, no big deal. Just chilling with your tennis court. That's fine. I'm into it. Oh, upper arm serve as I see. As a beginner. I see. Yeah, you know, we're trying. We're out there trying. Watch Haikyuu and you'll want to play volleyball. Okay, interesting. It scares me a little bit. I feel like I'm, yeah. I'm gonna keep to like, yeah, one sport. Hopefully. If you try to eat up too many sports, you're gonna go crazy and, yeah, you know how it is with hobbies, right? Visiting your dad's place, I see. All right, y'all. I don't know. So that's been a week. And then obviously the other funny thing is that, you know, so I've had this idea for several months to make an iceberg meme about SQL, right? And we were sort of workshopping it with friends and like thinking about different things that we could put in each of the levels. So I finally like went ahead and made this iceberg meme and tweeted it. And goddamn, that was a tweet. People were like, are retweeting it everywhere, like liking it, this, that. It was a fun experience. It was definitely the most viral tweet I've made, and it's been a pretty big inflation of the old ego, if you know what I mean. I'm like, hell yeah, viral tweet, baby, let's go. I'm getting like notifications on the phone all day, getting like, you know, get that dopamine drip turns into that dopamine stream, and then all of a sudden you're like, can't concentrate because your phone's blowing up for people retweeting your hilarious iceberg meme. So that's been pretty fun. Do I consider Twitch a hobby? Yeah, that's a good point. Twitch also has another natural back pressure mechanism, which is that you can only really do it one time per week if you're me, because I don't have time to really do it at other times. So that's a good point. I've been sustaining. It's absolutely a good point. Royalty check for 2% of the likes. Yeah, you know, I would donate those if I could. I would donate those if I could. Null bitmap helped a lot. Ideating this iceberg, you know? So, shout out to Null Bitmap and all the other homies. So, you know, I actually wasn't going to... We were just going to do some regular programming on the stream. But Null Bitmap actually had a good suggestion, which was we could go through the iceberg and talk about the layers. Would that be fun? Or would that be stupid? I can't tell. We could try it. I tweeted out that I would be going over the iceberg just to see if people would join from Twitter to see if they could look at the iceberg, but we could go through it. You get fired if you're streamed unless they let you work on open source. Oh yeah. Meta and open source, not a thing that really goes together too well, I don't think. But yeah, so all right. I don't know. Thought you'd know more of the things. So here's another funny thing about this meme, is that it's the first time I've used Figma. And Figma is a fun thing to do, you guys. I like Figma quite a bit. So here's the iceberg. I just love this meme. The meme starts with this man. A happy man. Chilling. Enjoying life. No cares in the world. Just happiness, you know? And so if you're a happy man, what do you know in SQL? Well, you know all the basics, right? You know about data types. You know about order by. You know about limited offset. You know the basic SQL. Like, this is what you do. You're a happy guy, right? You take your SQL class to learn how SQL works, and they teach you about it, right? They're like, okay, here's what a join is. Here's what foreign keys are. Here's what indexes are. Selected, cert, update, delete, null, blah, 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 right? All of this stuff. And ORMs, maybe. I don't know. Do ORMs belong at level 0? Maybe they belong lower down. I don't know. I don't really know. But why is this thing... Okay. Why is ORMs up there? I don't know. I just figured that, like, when you're, as a basic beginner SQL user, you're going to learn about an ORM a lot of the time, because sometimes when you learn SQL, they like put it there. But an ORM, right, is the object relational mapper. So it's like if you're using a language like Ruby on Rails or whatever, you're going to get active record. And active record is how you're going to think about SQL. It's the Django or Rails way in, exactly. So it could go anywhere, right? It could go here, it could go here, maybe. It kind of depends on how you learn it, right? Yeah. We have this great language, SQL. By the way, we all hate it and use these other things to write it for us. Exactly. I've been thinking about another meme with my friend, which I think is going to be pretty funny, which is about... So, like, people love to fight about whether SQL is good or not, right? They're like, oh, yeah, SQL is great. Or actually, data log is the one way. Or like, actually, no, SQL is great because, it's compatible with every tool in the entire world, but it's super flawed. And there's that meme with the guys throwing chairs at each other from American Chopper, which people often like to use for like a very discursive argument that is strong on both sides. I feel like that's going to be a banger meme. So we're kind of working on that one. I've become a meme producer. That's the new lifestyle. Meme production. Who controls the memes controls the universe and Twitter. But yeah, I don't know. ORMs. For those of you who don't know, an ORM, it allows you to say that an object in your programming language is associated with a table, basically. And so you can make properties on the objects, and then those get reflected into a table in the database. That's what ORM is, like active record. Or Django. All right, we're going to level 2. Level 1, we get this. Level 1, you're this guy. You're super happy. All's well. Level 2, I don't know. Like your hair, you kind of forgot to gel your hair this morning. Maybe a little bit less happy. Look at the body language. Look at the difference in the body language. This guy, chest out, confident, excited. Body language down here, a little hunched over. Starting to worry, maybe. It's like, maybe I'm having not the best day in the world. The first guy's really great, right? I feel like this should be an emote, honestly. It's such a good emote. It's ready to greet the day. This guy, it's like, well, it's still blue sky out, but I don't know. Maybe just not having the best day necessarily. Just an average neutral day. Take a look at some of these things. What's in SQL? Close enough to feels good, man. So I don't know. We got ACID. What's ACID? ACID is how databases deal with their transactions. Databases and transactions and ACID, these kind of go together, right? Kind of emo-y. Transaction is how you take multiple statements and group them together and run them in a way that's a couple of things together. Atomic means that if you have like a bunch of statements in a transaction, they either all execute or none of them execute. That's what atomic means. It's not what you drop. That would have been pretty funny. I should have put drop like right above ACID. That's a good suggestion for next time. For memes. So, atomic means all the statements execute or none of them execute. Consistent's kind of a funny one. Consistent is not what people think of when they think of consistency in distributed systems. Consistency in ACID actually means whether the database keeps track of the constraints that you have on tables, right? So in SQL, right, we can make these things like check constraints or foreign key constraints or unique constraints, all of these things, right? So consistent in ACID means the database respects these constraints and doesn't allow you to violate them. So a little different from normal consistency, but that's what it means here. So isolation, the I in ACID. It's more confusing. Probably the most confusing letter in ACID. The isolation one is about whether transactions see what's going on in other transactions. So ideally, when you would think about a transaction, it's like, well, what do you want out of that transaction? You want to, it's kind of all going or none of it's going. And hopefully when there's concurrent transactions going on at the same time, some other transaction isn't going to see an incompletely finished state, right? That's what isolation is about, more or less. And there's different ways of handling it. It gets really complicated. But at a high level, isolation means two transactions that can't see inside of the other transaction. If you're using a good isolation level, that is. And there's all sorts of horrible complexity there. But I think from that, when you think of ACID, you think of these things are isolated. You can't see inside other transactions. And D is durable. D, I don't know what people really mean. Like people just basically mean that your like statements execute properly all the way through and they get persisted. Is that what the D means? It seems like an obvious one in a sense. D means when you write something to a database, it stays in the database forever. Forever. All right, so ACID. And transactions, they go together. You learn to use a transaction maybe in level 1, right? If something crashes, you don't use data. Yeah, maybe that's a better way of saying it. All right, so query plans and explain. You guys know about this because we do this stuff all the time on the stream, right? You are running a statement and you want to know how it works, right? So you run explain on it. You guys know about explain, right? Let's check it out. We're gonna go to the shell, create table A int primary key, B int, C int, D int. And we're gonna say explain select star from A. What does the explain mean on this? It says, it explains to you how the database does its job. It's a cool thing. Okay, so here's another thing, you guys. Today is Edward Codd's 99th birthday. All right? Edward? Is that his name? What the heck is this guy's name? Ted. No Edward. I never know this guy's name. There's a great article about it, though. 99th birthday. He's not alive anymore. But there was kind of this cool thing. What's the relational model about? Edgar, Ted, Eddie, whatever the... There you go. Thanks, guys. This is the basics. The stream is even named after this guy, and I don't know his name. It's kind of sad. I need to work on that. What's the relational model about? It's about letting you get data out of your database without telling the database how to do it. That's a big thing. That's a big thing. So you don't want to have to say, read this table, then that table, read this row, then that row. You want to say, give me this data in a logical sense, and the database will figure it out. So explain lets you figure out what the database is actually going to do that, right? So here, this basic explain select star from A, it says it's going to read the whole table with a full scan, right? There's no filters on it, so it can't do much else. But if I add a filter, let's say select star from A where B is equal to 3, B is not an indexed column, so it's got to do the same thing and add a filter on top, right? That's kind of cool. Tells you what it's doing. If I were to change it to use the index, the column that's actually indexed, it does a different plan, right? It's able to do it more efficiently. And so this is what explain is about. So you learn this, maybe. You learn this because you're this guy, right? His name is actually Edgar Frank Ted Codd. Okay, great. So maybe I got it right then, somehow. All right, so explain and query plans, right? What's funny is that people on Twitter really took this very seriously. They were like, okay, everything must be perfectly precisely categorized or else it's wrong. So these are sort of some random concepts, right? They're just sort of random concepts. Window functions are about, so you know about aggregates. That's a group by. A group by and an aggregate is kind of a basic thing. Everyone learns that. You can sum up groups. But a window function is different. It allows you to do a kind of aggregate-y operation, but on a line-by-line basis. So if I wanted to calculate a running sum, for example, across a column, I could use a window function to do that. They're kind of confusing. And people start to be like, oh God, window functions are horrible. But dude, they're just on this guy's level. Outer joins, right? We know about outer joins. It's about nulls. It's about missing matches, right? An outer join lets you say, join two tables together, but what do you do when you don't find a match? Do you put a null or do you do nothing? That's what outer join is about. Window functions got to be next level? I don't know, man. I don't know. I don't know. So common table expressions. These are about with clauses. This is with clauses. Oh man, you know what would have really been fun? I should have created this meme on the stream in a collaborative way. That would have been sick. We should have done that. Because you know, people like to do that thing where they put like S tier, A tier, B tier on stream. I should have done that. Okay, next meme we can make it collaboratively on the stream. That'll be good. But this one's kind of baked. I'm not gonna edit it at this time. So common table expressions, this is where you can say with. You can say with X as, select 1, 2, select star from X, right? So this with thing is called a common table expression. It lets you sort of factor up your SQL, right? Inverted indexes, we've talked a lot about these on the stream. Inverted indexes are about indexes that index containers of things. That's the way I like to say it. Forward indexes create an index from a scalar value, like a 1 or a 2 or a 3, back to a row. Whereas inverted indexes take a container, like an array or JSON or text, and make many index entries pointing back to that original row. I don't know why they're called inverted. It makes no sense. They should be called container indexes or something. What's up, Dom? Thank you for the 12 months, 1 year. Appreciate your support. We're explaining the meme. We're explaining the meme to maximize engagement. What's up, Bruncell? Bruncell? Are you Brun voluntarily celibate? Okay, so what's key set pagination, you guys? What's key set pagination? You got to know the channel because of the meme? Yes, we're talking about top of the funnel content for the channel. You tried to dissect SQLite's query engine code and then you stopped. So key set pagination. So key set pagination, do you know there's something famous? Sorry, was that too much of a roast? I couldn't help it. But so with key set pagination, it's something to help you avoid a big problem, which is, you can say something like select star from T, limit 100, offset 300, right? So this is when you're, this is when you're implementing like a thing on the web where you want to have pages of content, right? The first 10 blog posts and then the second 10 blog posts and the third 10 blog posts, et cetera, et cetera. And the tempting thing is to use limited offset, but the trouble is that this is expensive. And the reason it's expensive is that the database has to scroll through all the data in order to figure out where the offset starts. So this offset thing is really expensive. And you can actually see it since we're talking about explain. You can see what we do in CockroachDB to implement an offset. And we use something called a limited scan. But as you can see, we've got to do a limit of 400 rows. And that's 100 plus 300. And the reason is that we don't know where to start, right? So limited offset is kind of inefficient. Key set pagination is a cooler and more efficient way of doing pagination where, as a client, you pay attention to the last key that you saw when let's say you're doing 100 blog posts at a time on a website. You pay attention to the 100th key that you saw. And instead of just doing a limit or an offset rather of offset 100, you can say select star from A where, let's say A is my ID, where A is greater than, my ID is, 305 or something. And then I say limit 100, right? And so if you look at the explain here, it's much more efficient. And it's because we get to start at that key that we specified. So 305, that's called key set pagination. And it's an important technique if you want to do paginated queries. All right, what's next? We got order by and aggregates. This is a little trick, little neat thing, but it's a little known fact. You can say select star from, actually, how does this work? Order by and aggregates. So what's an aggregate that needs to see an order by? So maybe in an array ag. So I wanted to say something like select array ag of B from A group by C. So what this is going to do is find all the things where C are the same, and it's going to array ag them together into a group. So let's actually insert some data here to make it clear. Insert into A values 1, 2, 3, 4. Then let's do like 2, 2, 3, 4 maybe. Let's keep the 3 the same a couple of times, basically. All right. And then we're going to do a 4 group. And this one's going to go up to 5 or something. Okay, so let's take a look at our data. Looks like this. So I can say select array ag of B from A group by C. And so this gives me back these kind of funny little things, right? So let's actually say select array ag B comma C. So this is saying for all of the rows that have C is equal to 3, let's make an array of all of the values of B. That's what this is about. All right. So kind of cool. But little known fact, you can actually add an order by clause inside of this array ag. I think. Can I? Order by B desk. Yeah. How crazy is that, you guys? So I can actually say, I don't want the order of 2, 3, 4. I want it to be in reverse order. So this is what this order by within aggregates thing means. You can sneakily add this bizarre order by thing inside of an aggregate function, and it's going to do it in a different order. Isn't that very neat? So if I look at the explain for this, what does it do? Well, it has to use a window function. I actually didn't know that, but there you go. Now you know. It has to use a window function for some reason, groups it together, and then it gives you this output. So that's what order by inside of aggregates are. All right, next we're going to do stored columns. So stored columns, kind of a cool thing. All right, so this is about indexing. Create index on A of D, let's say. All right, explain, select star from A where D is equal to 10. All right, and we're actually going to make a special query. We're going to say select B from A where D is equal to 10. How does the database satisfy this query? That's the question. How does it work? Well, we've got an index on D. We've got a primary index on A. And B is just sort of in the table. It's not indexed yet. So how is the database going to satisfy this query? I want the B value from this table where D is equal to something. I've got an index on D, so I can quickly skip to the area where D is equal to 10. That's great. But then how do I get the B value back? So what you have to do is you have to jump back to the primary key, since that's the only index that contains the B value for the table. And we call that an index join. Sometimes people have different names for this, but in CockroachDB, we call this an index join. And it can be expensive because, well, it's just extra work for the database to have to do, right? You find the value, but then you've got to go somewhere else to find some other value, right? So twice the work, twice the seeks. And that can be a bummer. When you have an index that's like this, that you want to be more efficient, you can use something called a stored column to make the index what's called a covering index. And a covering index is one where you do not have to do any index joins to get the particular other column that you're interested for, right? So I can say, instead of just saying create index on A of D, I can say create index on A of D, storing, and then I can put a B value like this. That's called a stored column. Is that what I actually even meant here? I actually think that I didn't even mean that here. This is something else. Well, you're learning twice the extra stuff right now. This is this is called stored columns is kind of an ambiguous term. It can mean two things. I'll go over both. This is called covering index. This is called stored columns and covering index. And if I do an explain again, then what you get is a more efficient plan. You don't have to do an index join because the extra value is available right on the index. No extra hops. Very cool. There's another kind of thing called stored column where I can make a stored generated column. So if I wanted to make some new column in my table, it's always just generated based on a function. So I don't have to specify it every time. I can say something like this: alter table A, add column E, and I say something like generated always as B plus C, I think. Is this how it works? Stored or something? No. Add column E, maybe it's like this, as B plus C stored. I actually don't even remember the syntax for this. CockroachDB stored column. Computed column. How do I do it? Oh yeah, I just forgot the type. Okay, so I'm close. Add column E int as B plus B stored. Okay, so if I say select star from A now, you can see I have this extra column E that's computed as the sum of B plus C. But the key is that since I specified this stored column, this stored keyword, it's actually going to write down the value on disk. So it's not going to compute this on the fly. It's going to write it down in an actual column on disk, but you could just never specify when you insert data. It's always just computed automatically. There is another thing you can do. If I were to add a column F, the same thing, and I made it virtual instead, well, this actually looks identical, but under the hood, this is going to get computed on the fly, you guys. Isn't that crazy? It's going to get computed on the fly. This isn't stored on disk. It's just computed on the fly when you select. So I feel like that's pretty neat. Pretty neat. Stored in virtual columns. All right, back to the meme. Skip this song. It's annoying. Stored columns, computed columns. Oh, we just did both. Okay, we did stored columns. We did computed columns. We did these. Key set pagination transactions order by. That just leaves normal forms. So normal forms. If I had to define to you all the normal forms, I could not. This is something that they teach you. Normal forms are about data modeling, and they're about making it so that your tables can compose nicely, kind of. You got like join tables and stuff like that, you know. You got like, don't put extra attributes in tables if you can compose them out. Don't restore columns in multiple places. It's kind of stuff like that, right? And to be honest, I actually don't know this stuff particularly well. Normal forms database. I actually couldn't define you all of these different normal forms. You know, there's a lot. You got first normal form. You got second normal form. You got third normal form, you know? You got COD normal form. You got fourth, fifth, sixth, you know? It's like, I don't know this stuff. I don't think you need to know this stuff. Sometimes people think that they need to know this stuff, and the answer is that you do not need to know this stuff. It's like really not that important. Stored in virtual columns look similar to materialized view and normal views in concept. Is that true? Yeah, I think it's a similar thing. Nah, yeah, it's true. It's similar. Normal view is a virtual thing. It's not stored anywhere on disk. Materialized view is stored on disk. The difference is that this is column by column, so it's like a little bit different. But yeah, I think you're right about that. All right, y'all. So we made it through levels 0 and 1, or whatever you want to call this. Do people have any questions so far about the concepts on 1 and 2, 0 and 1? Otherwise, we're going right down to version 3, you guys. We're talking underneath the ocean. We're talking about, we're getting deep. We're getting super deep. Wonder if normal forms are being used. People definitely use them all the time. I just don't think you need to like memorize them or anything like that. Indexes on array column type in Postgres are fun. You mean the forward indexes or the inverted indexes? Yeah, I think you're right about that, Lithium. They're more about business logic and data modeling rather than the database internals. All right, so we're gonna dive deep under the surface, you guys, down into the early lower depths of this iceberg. And first, we're gonna have to take a look at this man. All right, so we started out pretty happy, confident, excited. We forgot our hair gel, and now we're down into, we are having a bad hair day, and the curve of our spine has inverted. It's going in the other direction. First, we were confident, then we were straight up and down, and now we're kind of in the opposite direction. And you know, like, this kind of reminds me of another meme where you may have seen this meme, right? About the direction of that people, what the heck? I don't actually know how to use Figma. Pencil, maybe? Oh, God. Give me the pencil. Make it green. This is the meme where we're talking about what direction people are angling, right? This guy angling straight up and down, you know? This guy kind of angling in this direction. This guy's angling in this direction, all right? And you know what that means? That means he's unconfident. That means he's kind of leaning forward, freaking out about life, not feeling great, and his hair is a mess, absolute mess. You know, we're talking about things are not going well for him. And that's because we sank under the surface of the iceberg, all right? We sank under the surface of the iceberg. So let's take a look at some of these concepts. Starting from the left, we got connection pools. So who's familiar with connection pools? Connection pools are a client-side concept that you start to need to understand when you're building SQL database applications at scale, right? Because here's the idea. Every connection that you make to a SQL database typically can only just do one thing at a time. It can't really multiplex stuff, and it's because sessions in SQL are stateful. And so you open a session, and you can set things inside of the session. You know, they may be inside of a transaction, or they may not be inside of a transaction. And that state is pinned. One session equals one connection most of the time in SQL. And it's a little old school, a little awkward, not necessarily great, but it is what it is. And as a result, what you have to do to deal with this is that you have to have one connection per thing that you're doing concurrently. And to deal with that, since connections can be expensive, we have connection pooling, where you have a bunch of connections that you're opened at once, and you can limit the concurrency that you're using to talk to the database. Right? So if you have 10,000 people all trying to talk to the database at once, it may not be great, but maybe you wanted to funnel them through only 100 serial connections. That's one reason for a connection pool. Another reason is that it's expensive to start up a connection to a database. You have to do authentication, which sometimes has to do hashing. There's all sorts of like startup business, and it can be kind of expensive. So a connection pool is a way to cache connections and reuse them for longer than just a single session or a single statement that you're sending to the database. So connection pools are important for performance. Okay, so that's what that is. So I thought this was funny. So look, we learned about ORMs up at the top. And then at a certain point, you sink down below the surface, you get a little sad, like this guy, your hair goes bad. And part of the reason is that you realize that ORMs just create absolutely terrible queries a lot of the time that are difficult to debug, difficult to understand, and difficult to change. So this is like people start to realize, like, shit, my ORM makes bad queries on my behalf, and I'm not happy about it, right? So that's what this is about. Not much to it, it's just kind of a joke. Lateral joins. Lateral joins are kind of interesting. Most people, I feel like, don't really think about what lateral joins are about. And it's because they're sort of optional when you specify them. You don't really need to say join lateral at any time. But the purpose of join lateral is that it allows you to connect tables that are used in subqueries. Now that I'm trying to explain this out loud, I basically don't really understand lateral joins, but check it out. So in SQL, you can make a subquery that is it has this notion of being correlated in the sense that it's not completely encapsulated within itself, right? So you can make a subquery in SQL like this. Look, select star from a where, and then I can make a subquery something like this. Where E is equal to, and then I can make a new subquery like this, select A from A limit 1, right? This is a subquery, but it's not a particularly interesting subquery because it doesn't really do anything special. I could make this something called a correlated subquery, which means that it references variables from outside of the subquery. And at that point, the database has to do different stuff. And you can sort of turn this into something that we call a lateral join. All right, I'm going to leave the explanation at that. Obviously, yeah, lateral joins, man, they're crazy. Bah? Moving right along, we got the dual table. So the dual table is this funny thing. It exists in Oracle. It actually doesn't exist in Postgres. It doesn't exist in Postgres, but it exists in Oracle and it exists in some other databases. And what it is a table that has a single row with no columns or something like that. And the purpose of it is that in some SQL dialects, you can't just say something like this. You can't say select one without a from clause. You need to always have a from clause. And in order to deal with that, you can make a table called dual. It's going to look something like this. Create table dual with no columns. And then instead, I guess I have to insert some data into it too, right? I have to say insert into dual values. Is this even possible? It might not be. It may be difficult to construct dual in Postgres. I'm not sure how you get a value into dual because it doesn't have any columns. But anyway, you can do something like this. If you don't have select one available in your database, you can say select one from dual. And then assuming there was always one value inside of it, you would get a one back here. And then that's a way of simulating the ability to do this. You use dual mostly for making sure that we've connected to the database when application started. Yeah, that works too. You can say, select one or select star from dual. It's the same thing. Same kind of thing. All right. So recursive common table expressions so we talked about common table expressions right before, right? Where it's like with x as select 1, 2, select star from x. So you can also say something like this with recursive. And I don't know if I can construct one of these from memory. I don't really remember the syntax, to be honest. But the point is that you can actually design a common table expression that refers to itself in order to do stuff like traverse a table that looks like a graph. So if you had a big table where there's IDs on the left and then like a next reference on the right, you can kind of construct a linked list table and you can traverse through that thing with a recursive common table expression. It's kind of a neat trick and people use it for stuff. But I don't know, whatever. Kind of crazy. Dual in Oracle has one column named dummy with one row with a value of x. Okay, so then we could implement dual in Postgres syntax, or Cocker should be drop table dual. You could say create table dual dummy dummy text as select x. So then I have the dual table. Good for us. Twitch is storming advertisements just like recruiters spilled jobs in GopherCon. Did Twitch like up its ad rate or something? Oh, if I don't have columns, can I use default values? That's a good question. Drop table dual, create table dual, insert into dual default values. Yeah, look at that. There you go. Should have had default values to this iceberg. 6 ads in a row before you could watch a stream the other day. Jesus. I think that people can configure it, but I actually don't really know how. I haven't really played with it. I didn't really know. I should look into it. I did get a notification that they like changed something about ads. So maybe I should just find a way to like disable them. I'm not really sure if you can, is the thing. I don't actually really know if you can just turn them off. Is it better to avoid mutexes over channels? In Go, and is a good idea when you're using maps? Databank fanboy? Oh, hell yeah, dude. That's a fantastic, what a wonderful Twitch name. Okay, just for that, I'm going to answer the question. Is it better to avoid mutexes over channels in Go? And is it a good idea when using maps? So your question is, should you prefer using channels or mutexes? I think channels are easier to use. And in general, I think they're better to use. I think mutexes you could use if you need some performance, but they're sometimes harder to get right. I think channels are a nice abstraction until you run into like performance problems. I don't know. I like channels. Then again, mutexes are nice too. It really depends on the use case. Like if you just have a sort of simple thing where it's like you have a critical section in your code and you want to use a mutex for that, you should use a mutex for that. So it kind of depends on what you're up to, I would say. All right. So next up, we got cursors. So cursors are a way that you can read values from the database one at a time, rather than having to read the entire thing at once. And you can kind of do paging a little bit. So you can do this in SQL using text, using SQL itself, or you can use a protocol level cursor. So I can say something like this: declare foo cursor for select star from A. All right, we have to be inside of a transaction to use it. So I begin a transaction, I say declare, and then I can say fetch one foo. And I can say fetch one foo again. And we can do it over time, and we get the whole contents of the table as we keep doing fetch. So this is what a cursor is. Thanks for the 200 bits, Mr. Wormhole. You used to use cursor like in 2010 in stored procedures. Good old Microsoft SQL. All right. So stored procedures is a way of creating a function that the database can execute. It can do all sorts of stuff. You can make a cursor inside. You can do a for loop inside. You can do if statements. You know, it's like a little programming language inside of SQL. You can save this thing as a function, and then you can invoke it later in your database. You can even use it as computed columns. You can do all sorts of crazy stuff with stored procedures. CockroachDB doesn't support it yet, but pretty soon it might. In the next release of CockroachDB, it'll support user-defined functions, which is sort of a building block for stored procedures, which I think is pretty exciting. And we actually did a couple of these things we actually did on stream. We implemented cursors on stream. So if you go back into the YouTube or whatever, you'll see we actually implemented cursors, SQL cursors on stream for CockroachDB. And user-defined functions we played around with as a basic prototype like years and years ago, but the team has actually gone through and productionized it, or really done it from scratch correctly. The thing we did on stream was really shitty and bad. But anyway, so it's pretty cool. User-defined functions will be supported in Cockroach pretty soon. All right, so optimizers don't work without table statistics. The idea here is that, you know how we had this explain thing that we were looking at earlier? You kind of have this realization. The database is not magic. It can't just figure all of this stuff out itself. It needs to have an understanding of the distribution of data inside of the database. In order to do that, it has to collect statistics on the tables in order to understand that distribution. And without statistics, without allowing your database to regularly run statistics collection, it won't really be able to do a good job at making good plans. So that's what this is about. All right. Plan hints. So plan hints, sometimes the database doesn't get the plan right? That's what we were just talking about. Sometimes the database doesn't get the plan right. And you can influence the database's planning if you want. Select star from A. Select star from A where D is equal to 4. Okay, and let's take the explain. This explain plan, wait a minute. Where was the one that we had the index on again? Show create table A. We have an index on D. Select A from A where D is equal to 5. Explain. So the way that this one works is it can use this index. Let's say the database got it wrong and we wanted to use a different index. Well, we can hint it. We can say select star from A at, and I can say, let's say I want to use the primary key for whatever reason, even though it's a worse plan because it has to do a full scan. I can ask the database to use this index and it will. That's what a plan hint is. All right. MVCC garbage collection. Okay, so we were talking about isolation a little bit. We'll get to that soon. The way that databases, some of them implement isolation is by using MVCC. MVCC stands for multi-version concurrency control, and it basically just means that anytime you insert a piece of data into a database, you're not just inserting the data carte blanche, you're inserting it with a timestamp. And when you delete a piece of data, or when you update a piece of data, you're not wiping the original data that was already there for a given key. You're actually just adding a new key next to it with a newer timestamp. So that's why it stands for multi-version concurrency control. It means that every piece of data, every time you update it or delete it, you add a new version. You don't overwrite it. And the purpose of this is to be able to do isolation levels in terms. The database needs this information to be able to provide isolation. Is why we do this stuff. So what is MVCC garbage collection? Well, what it means is that since we're constantly adding new versions of data and not overwriting them altogether, it means that the database would grow indefinitely if you kept updating stuff, right? Because we're never removing those old versions, and that can't be good. It, in fact, is not good. And so databases have to do garbage collection, which means deleting the old versions of keys off of the disk in a process called MVCC garbage collection. And you have to make sure that the database can do this. You can't turn it off or else your database will grow forever, but it is a performance overhead. So that's why this is sort of around. You're this guy, your hair is getting a little crazy because you just realized that your database has to do all sorts of bullshit behind the scenes in order for it to continue working properly. There are no non-nullable types. This was, I think, null bitmap's idea. I think the idea here was just that you can't make a data type that doesn't allow null in SQL. Everything, you can always put null in there. And that can be irritating. Even though you can say a particular column is non-null, you can't have a type that's non-nullable. Is that part of vacuuming? Yeah, so Postgres, it calls MVCC garbage collection vacuum. Vacuum does a lot in Postgres, but one of the things that it does is MVCC garbage collection. Vacuum also, like, it collects the table statistics, it reclusters data, it does all sorts of stuff. But yeah, one of the things it does is this MVCC garbage collection. All right, we're diving deeper. We're on level 4. We've grown a goatee. Our hair has gone back to drooping. And I would say that we still sort of have a forward lean, but we've also like expanded a little bit. You know, we're no longer just concave. We're now convex. We've become a convex person, and we've gained goatee, and our eyes do not look happy. You know, we're starting to look a little bit unhappy here. So that's what this is about. We're getting deep. We're getting deep. Let's take a look at some of these. Count star versus count 1. All right, so here's a weird thing. You could say select count star from A, right? People know what this does. It counts up all the data in the table. He looks smug, does he? I think if he was smug, he would have a little happy corner, you know? I think he's just getting resigned to life. He's getting resigned to life. All right, so count star versus count 1. I can say count star, and it's going to count up all the data in the table in number of rows. And there's also a thing called count 1. And so people are sort of like, well, what is this count 1? You can do the same thing. And there's a common question, like, what is the difference between these things? There's kind of a weird thing where in SQL, you can say, in certain contexts, you can use a number to refer to a column. So I can also say count A from A. And in some contexts, people think, well, okay, this one thing actually refers to this A because it's the first column in the table, but it actually doesn't, I don't think. It's kind of a weird one. So what is the point of count A versus count star? Let me explain that first of all. So I said insert into A values, and I put some null in here, like this. Oh wait, we can't because of this problem. Okay, so we're gonna put 10, and this one will be null. All right, so we have a null in the second column there. Select star from A looks like this now. It's got a null. So what happens if I say select count of A from A? I get 5. But if I say it's count of B from A, I get 4. And the reason is that it doesn't include nulls. All right, so that's simple enough. And so you might think, well, since in some contexts you can refer to columns by ordinal, saying count of 2 from A would give me back 4. But it actually doesn't. It gives me back 5. And the reason is that what this is doing is it's treating 2 as an ordinary projection. Like I can say select 2 from A, and it just gives me back all 2s. And so when I say select count 2 from A, it's the same as saying select count of select 2 from A. So it's like very stupid, and people get confused by this all the time. What happens with star if all columns are null? It just gives you the number, the rows back. So if let's make a new table, create table B, A int, B int, insert into B values 1, 2, insert into B values null, null, select count star from B. It's going to give me back 2 because the count star does not pay attention to nulls. Even though you might think it should, it does not. So there you go. There you have it. Just a weird thing. That seems somewhat inconsistent. Said everybody about SQL. All right, so next up, we got serializable restarts. Okay, wait, we're not going to do that yet. We're going to do isolation levels. This is a deep subject. That's deeper than my ability to really understand it, to be honest. But here's the idea of isolation, right? We were talking about how isolation is about having 2 transactions not see inside of each other. So in SQL, you can specify different levels of isolation. You can say things are allowed to see inside of each other if you want. If you want to do that, you can say, let me make my isolation level something called read uncommitted, or something like that. And what that means, read uncommitted isolation level, means that you are allowed to see data that has not been committed yet. It's just in progress transaction data. Why would you want to do that? I don't know, but you can do it in some databases. So that's one isolation level. Another isolation level is read committed, which allows you to only see data that's been committed, which sounds like pretty good, but for various reasons, it's not that good. There's something called repeatable read, isolation level, which repeatable read makes it so that inside of a transaction, anytime that you do a particular read, like select star from A, if you repeat that multiple times within a transaction, you always get the same value back, which sounds like decent, but it's not like that good because of a problem that's written over here called phantom reads. And phantom reads happens. It's what we call an anomaly, an isolation anomaly. And what a phantom read is that just because you know that you can say select star from A where something something, and you say it twice and you get the same thing back, it doesn't actually mean that you're not allowed to say after you do those two things. It's hard to describe. You do a different select from a different part of the table, and then the thing that you get back in that other part of the table is from a different point in time than the point in time that you got the first two at. So you'll get this sort of inconsistent view that doesn't seem inconsistent at the outright. It's not violating repeatable read, but it's still violating something because you're not seeing just one picture of the table as you're doing the transaction. It's a little non-intuitive behavior. So that's what happens at repeatable read isolation level. Then there's something called snapshot isolation, which is like a little bit better. It is supposedly able to give you a single snapshot of all of the data in a database, and you will never see two versions of or two rows that exist at two different times in snapshot isolation, which is cool. But it permits something called, what does this permit? It permits something called, or wait a minute. Is phantom reads for repeatable read or is it for snapshot? No, I think I got it right. And then there's this other anomaly called right skew. And so right skew is this weird thing that you can happen inside of snapshot isolation, which like has other problems. I don't know. It's right skew is kind of complicated to explain. I'm quite bad at it. Someone in the chat, our friend Null Bitmap, who we love to talk about because he's a great writer, wrote a good blog post about this, which I really like, called "What Does Right Skew Look Like?" So if you're really excited about it, take a look at this blog post, and he's going to be doing a much better job of explaining this stuff than I am. So that's what right skew is about. Something that can happen at snapshot isolation. All right, so that's isolation levels. And then the final isolation level, well, it's not really the final one, but one that's like quite isolated is called serializable. And serializable does not permit right skew. It's a little bit better than snapshot isolation. You can also call it serializable snapshot isolation. And what serializable snapshot isolation gives you is it makes sure that the sequence, you can always construct a single serial sequence of all of the transactions that are happening concurrently and have that sort of history make sense. So there's no inconsistent state. You can always find some ordering of all of the things, all of the concurrent transactions that sort of make logical sense. There's no like weirdness in between the transactions. So that's what serializable snapshot isolation means. There's another one called linearizable. And I think the way that linearizable works is that it's more than just having a single consistent history. It's like, actually don't quite know what that one's about. It's like somehow slightly better than serializable. 90% of people who use SQL don't know about the different levels. It's probably true, and it's a big problem because the default in many databases is something very basic called like, I think a lot of databases just use like read committed by default or something like that. And that can lead to many problems and people can get very confused, which is why, we like to say CockroachDB uses serializable by default to sort of get rid of those problems. What's up, Ruben? They don't relate. Direct linearizable and serializable don't relate directly. I would believe that. Yeah, I should probably have a good, concise description of linearizable next time in my back pocket. That's the word. Serializable by default, so much code that won't retry queries. Right. So the kind of next thing that is related to all this is this guy. So serializable restarts require retry loops on all statements. So there's sort of some good things and some bad things about providing serializable by default. The good thing is that you don't expose your users to weird isolation issues. But the bad thing is that you do have to teach your clients to always be running a retry loop around their transactions and statements. And the reason for that is the database, in order to provide serializability, it might force you to restart your transaction. So that's what that's about. Post from our friend Kyle. Let's see if Kyle provides a nice, concise description of linearizability. If we assume that there's a single global state that each process talks to, we know that the atomically, great many histories, we know that each operation appears to take effect atomically at some point between its invocation and completion. I see. So actually, I thought that this was the same as serializable. I think what I just said about serializable is what the definition of linearizable is then, where every operation happens in a nice linear order. I did actually think that that's what serializable meant. Hasura is working on adding Cockroach TV support. Yes, I know. It's exciting. It's not necessarily just retrying statements, but also the code that led up to it if it involves computed values. Yeah, so it's sort of like if you can imagine your database code is doing a transaction inside of a closure, which is a typical way of doing transactions on the client side. You would need to retry that entire closure. Yes, restart the entire transaction, exactly. All right. So we did sort of this isolation. We did the serializable. We did count star. Yay, distributed systems, exactly. So let's talk about generator function zip when cross-joined. I think this one's really funny. This one's really bizarre. So a generator function is something like select star from generate series 1 through 100, or let's do 1 through 10. So this the generate series thing is called a generator function because it returns multiple rows, basically. And there's two ways of invoking this. You can say select star from generate series, or you can say select generate series, and they do the same thing. Normally in SQL, when you cross join two things, it's going to take the Cartesian product, right? So if I have this table, I have this table A, right? And I have this table B. Normally, if I were to say something like this, select star from A, cross join B, I get the Cartesian product, which means that I multiply the number of rows in this one by the number of rows in this one, and I have one per that, right? Another way of saying cross join is just putting a comma like this. Select star from A, comma B. It's the same thing. So you would think that when you anytime that you do something like this, you're going to get the Cartesian product. But unfortunately, SQL does not like to make our lives so simple. And if I were to say something like this, select star from generate series 110, comma, generate series, I actually think this will do what I expect. So if I say it like this, I do get the Cartesian product. Let's do it with 2. But if I do something slightly different, but very similar looking, which is to get rid of the from and just do the 2 selects, I actually get something very bizarre, which is zipped generators, right? So instead of doing the Cartesian product, I'm just putting them side by side. And just because I don't really know why it's done like this, but this is just life. This is what SQL does if you have two generator functions sort of next to each other. They actually zip instead of Cartesian producting. Just a quirk. Weird stuff. All right, so we did that. Sharding, right? We know about sharding. Sharding, in some databases, you have to think about how to shard your data to distribute it, to make sure that your data can be spread across multiple computers. Some databases require that you think about how to partition your data so that it can be sharded. And, sharding is a big thing in many distributed systems areas, right? Just thinking about how to split up the work between multiple clusters of machines or multiple machines or etc. So it's about finding ways to partition your data for scale, basically. We know sharding. Zigzag join, this is kind of a fun one. So zigzag join, you might think, okay, so there's a lot of join types, right, in SQL. You're like, okay, there's inner join, there's outer join, there's left this, there's full that, right? Right. So the thing that a lot of people don't necessarily know is that there's kind of two types of joins from a very high level. There's a physical implementation of a join and a logical join. So when we say inner join, outer join, full join, those are logical joins in the sense that they are telling you what way to relate these two tables together. There's also two other ones that you can't really specify in SQL, but they do exist, called anti-join and semi-join. And anti-join and semi-join are saying, give me all the things on the left except for the ones on the right that match. That's an anti-join. And semi-join is, give me all the things on the left that do match things on the right. That's a semi-join. Did I say semi-join twice? Anti is remove the ones on the right. Semi is only include the ones on the right. So those are logical joins. Physical joins is something else. Physical joins is about how does the database actually select all of the data in the database that matches the logical join. And so there's a few types of these. There's like a nested loop join, which is where the database goes, for every row on the left, it goes to do a lookup on the right. Nested loop join or lookup join. There's a hash join where the database reads both sides, constructs a hash table for one of them, and then finds all the matches on the right side by looking up inside of the hash table. There's a merge join where the database makes sure that two tables are sorted and it merges them together like you would using sort of a insertion, or what is it called? Merge sort, I guess, not insertion sort. Like if you're thinking of like a merge sort in algorithms class, right? You're doing this recursive merge thing, and it's the same in SQL. Basically, you've got these two sorted lists and you're merging them together, and you can implement a join like that. And then there's kind of this other funny one called zigzag join, which I think is kind of cool. Zigzag join, I learned about it from this great talk about, it was about, who was it by? It was by the people who did Google App Engine database zigzag join. And there's a good YouTube video about it. And now I can't find it, huh? Aha, here it is. So this is a cool video.
My name is Alfred Fuller, and I'm going to talk about next-gen queries.
And this video explains what zigzag joins are. This is how we learned about them at Cockroach, and then we implemented them. But what a zigzag join is, it basically says, okay, so what's kind of crazy about Google App Engine database is that it doesn't really make you think about indexes. What it does is for every table that you have, it creates an index for all of the properties on the table. For all the columns in the table, it makes an index. And that's kind of cool, but like, how do you deal with the fact that sometimes people want to look things up by more than one property? So normally you could make an index that has more than one column, and you could use both of them to filter, right? But since you just have one index per column, you have to do something a little different. You can do something called the zigzag join business. And the idea with zigzag join is that you're doing more than one filter at once and more than one index at once. And so you take one property that you're trying to fix and you jump to the right spot on one of the indexes. And then you pick out the value that needs to be filtered on the other index. And then you jump to that index to try to figure out whether there's a match there. And if there is, you're good and you can return it. If there isn't, then you go down to the next thing on the other index and you see if there's a match on the first index. And you can kind of jump back and forth. That's why we call it zigzag join, because you're kind of hopping back and forth between two indexes. And you can use this for all sorts of stuff. Besides just this thing that I'm talking about, you can also use it for inverted indexes. It's kind of a handy little abstraction. It's like a more advanced nested loop join, basically. So that's what kind of a zigzag join is. Join algorithm is chosen based on lots of things. Table statistics, chosen based on the costs of the different plans that you can use. It's about whether, for merge join, for example, you have to have a sorted input or else it doesn't work. So if you don't have a sorted input, you've got to sort it, and that might be expensive. So it comes into the cost model, basically. All right, so moving on, we got triggers. So triggers is a way of telling the database to do an action when somebody inserts or updates or deletes data. The one that's built into all databases is called foreign key cascade. So in foreign key cascade, if you delete a row from the target of a foreign key and you specify foreign key cascade, it's going to go back to, wait, do I have that backwards? I have that backwards. If you delete a row that's the source of a foreign key. So let's say you had a zip codes table and you wanted to delete a particular zip code and it's referenced by 20 customers, right? The 10000 zip code. There's 20 people who use 10000 in your database. Normally, if you delete that row with 10000, it's going to say you can't do that because people are referencing that particular value. and it'll fail. That's the restrict mode. In the cascade mode, it's going to go and delete all the things that do reference it, right? So it's a quick way of wiping out a bunch of data that's related to each other with foreign keys. So that's kind of a trigger, right? A trigger, because when we delete stuff, it does some action. And in databases, you can also make custom triggers that use stored procedures to do different stuff custom based on what you want it to do. So that's what a trigger is. All right. All right. Next up, we got merge. So merge is crazy. I actually don't really understand merge totally. Merge SQL. Merge is really a wild thing. So what merge does is it allows you to do more advanced insert on conflict statements, basically. So in SQL, you can say insert on conflict. And if the database notices that a value matches a constraint that's already there, so like a primary key or a unique key in an index, instead of just failing, which is what it normally would, it will let you do an action, like delete the old one, replace the old one with the new one, replace everything with nulls, or various different things you can do with an insert on conflict. Merge is sort of like a more advanced version of that allows you to do like arbitrary weird stuff by synchronizing tables, I guess. I don't know. We have not implemented merge in CockroachDB. I don't know how it works. It seems kind of sick, but it's definitely down there. It's in the GoTman's domain. So getting to the end of this, we got two more. We got partial indexes. So partial indexes are kind of crazy. Let's take an example. Select star from A. Let's say create index on D on A of F where, so I can say something like where in an index, it turns out. So you can, this is called a partial index where you add a predicate to an index. So I'm going to say create index on A of F where F is greater than 7. All right, and so what this is going to do, it's going to only index the values that are greater than 7. Why would you want to do this? It's a good question. It's a good question. But what this will do is it says select star from A where F is equal to 9, I could say. And let's take a look at the explain for this. Right, we need to say select F from F because it knows it's not covering. So it doesn't want to use it. Fighting with the planner a little bit. This is actually not working as I expected. Maybe there's some weird interactions with virtual columns and partial indexes or something like that. Let's make a simpler example that doesn't use the virtual column. Let's say create index on A of B where B is less than 4. And then select B from B from A where B is equal to 2. And let's look at the explain for this one. All right, so here, this is what I was sort of expecting to see. Since it's a partial index and 2 is less than 4, it can use the partial index. So you see it uses the partial index right away. It jumps right to the right area. It gets you the value. But if I were to say select B from A where B is equal to 5, it cannot use the partial index because it's not that portion of the table is not indexed. That portion of the column is not indexed. So it has to use a full scan. So you can use it for all sorts of things. You can have like an index that only is updated for things that have not, like soft deletes, exactly. So for an example of soft delete is like create table users, ID int, name string, active bool, right? And so let's say we have this big, huge users table that we're always inserting into, but then like we deactivate users and we don't care about them anymore. And we only want to index the names of the active users. So what I can say is create index on users of name where active is equal to true, right? And so what this does is it's only going to bother making index entries for active users. So if I say insert into users values 1, Ruben true, and then I say select star from users, explain, select star from users where name is equal to Ruben. This is going to, maybe I need to, I think this is because the table's small and it's not a covering index. So it wants to do a full scan. I'll just... Oh, right. Very important thing, you guys. Of course, this wasn't going to work because we didn't specify active is equal to true. So let's try this again. Select star from users where name is Ruben and active is equal to true. All right, so the database couldn't use it before because it didn't know that active was equal to true in my example. So now that I've specified active equal to true, it's going to be able to efficiently use the partial index. However, if I were to say, update users set active equals false where name is equal to Ruben, and then try this again, where active is equal to false, of course, it's not going to be able to use the index because it's not indexed if the active is equal to false. So that's what partial indexes are. And you could use them for different use cases, but this is one of them. So it's pretty cool stuff. All right. Moving right along. What kind of info can you get about why that? Yeah, so there are all sorts of crazy stuff that you can do in many databases, including CockroachDB. So this is just a very basic baby explain mode. The next cooler mode is explain verbose, which maybe doesn't really do that much in a lot of cases. So let's ignore that one. Let's take a look at explain opt. So explain opt is going to use the optimizer plan as opposed to the execution plan, which looks a little bit different. In the optimizer plan, I can ask for verbose mode, and this is going to give me all sorts of interesting information about how it works, but it's a bit hard to read because it's sort of debugging information more than user visible information. But for example, you can see that it's using something with histograms, and it understands where the different values are within the histograms. There's telling you what the optimizer statistics have been collected, like how many nulls there are in a column and what the average size is, and all sorts of different stuff. And you can even use something even more advanced, which is called explain memo. And this is really only just for like super information junkies or database developers. I have to put opt. And what this gives you is the entire, so the optimizer uses this data structure called the memo, which is an efficient, compact way of representing a forest of different query plan trees by using these things with there's sort of group IDs, and group IDs can reference other group IDs. And within a group, you can have multiple different ways of satisfying the particular part of the query that's given by the group ID. So in this example, this G2 group can either be done with this guy, select G3, G4, which are two other groups, or it can use this other thing, which is, I don't know why it's even doing this right now, but this is related to like multi-region stuff. Maybe I'm in some mode that is looking at that. Anyway, so this is like the memo. You can use this to debug stuff, but it's not really very good for users. There's another couple of other ones, like there's an explain dissequel, which gives you a URL, and the URL gives you a physical plan. So if I had a bunch of different nodes in this distributed system, since CockroachDB is a distributed SQL database, it's going to have a lot of boxes. Like this blue box is node 1, but there would be node 2 over here, node 3, and you'd see the way that the information flows across the different nodes. There's all sorts of cool stuff you can do with this, but whatever. And then the last one is this explain vectorized, I think. How do I do this? Explain vec, maybe? So explain vec gives you a little bit more detailed information about the actual physical plan chosen, which includes these like efficient vectorized operators that we use to try to make the whole system go really fast. So basically the answer to your question is yes, there's like 1 million different ways to look at the plan, and all sorts of cool stuff to explore there. But most of them are really just for developers, database developers who are trying to debug what's going wrong. Okay, so next we got grouping sets, cube, and rollup. These are kind of some really weird ones that I also don't totally understand. And I don't think we've implemented them in Cockroach yet. But there's something in OLAP databases called like cubes. Data cubes, is that what this is called? Cube? I'm creating a data cube. And the way that these things work is that it gives you the ability to slice and dice your data across different axes and different dimensions by giving you different aggregate views on subsets of the data. And grouping sets, cube, and rollup are sort of 3 ways of interacting with that functionality. As you can see, I don't really understand grouping sets, cube, and rollup, but it is a thing that people like to use, I think, in the world of analytics for reasons. All right, y'all. We made it through the goatee zone. Cubes are dimensions in fact. Group by of group by. Yeah, that makes sense. That makes sense. There's a recent blog post about Postgres that purported to explain halving, and the internet went wild about cube instead. All right, so we're sinking down to the second to last chunk of this iceberg before we get into the abyss. And as we can see, our boy has developed some issues. Our boy has grown a ponytail like mine. I've got a ponytail. Does that mean I'm like this guy? He seems to have a neck beard. He's got some double chins, you know. He's looking a little sad. Like, look at this expression. It's not great. He's not very happy. His eyes are looking a little unhappy. His hair is getting increasingly unkempt. He's like, yeah, you know, he's growing in size. I think he's still angled in this direction. So what's going on this level? So we talked about normal forms. Denormalization. This is about people realizing that normal forms aren't always good, in fact. They're not always good. It's not always good to decompose your data into many different little tables that you join together. Sometimes it's good to denormalize the data, which means storing duplicate bits of data across multiple tables. And we do this because it can be more efficient. We avoid those index joins. That's really what it's about a lot of the times. Avoiding extra joins, avoiding extra hops. Transaction contention. Maybe this should have been up here. I don't know. Transaction contention says that in a database that implements serializable isolation or a snapshot or other different ones, transaction can contend. You can have two people trying to write or read the same key at the same time, and the database has to decide what to do with that. And sometimes it requires restarting, retrying, or delaying transactions, and that can slow down the database, and it can be tricky to debug why your workload is running slowly because of contention. Not to make this a complete hashtag ad about CockroachDB, but actually CockroachDB does provide some pretty nice tools for helping you understand why transactions are contending with each other that, you know, the team has been building, which I think is pretty cool. You can see it in the UI. You can see people who's contending with who and why. I think it's pretty useful tool to try to figure out that stuff. Oh, and by the way, I think we just hit 4,000 Twitch followers. That's kind of cool. Thank you for Zapak, 4,000th follower. Appreciate you guys. Select for update. So does denormalization have actual benefits from the database perspective, or is it just easier for certain applications so that you don't forget to update certain rows? It does have actual benefits. So denormalization is about the other thing, the other direction that you're saying. It's actually making it so that things are duplicated. Denormalization means duplication. And that can mean making your application have to do more stuff to be smart rather than less. And the reason we do this is for performance on the application side. Sometimes you might decide we should denormalize for performance. It's a concept. It happens sometimes. It was very hot in the NoSQL days. SQL, maybe you have to do a little bit less. I'm not sure. But, you know, it's generally the idea is like you don't necessarily want to go crazy making a ton of different little baby tables that join together if you're in a transactional database. In analytics databases, there's lots of good reasons to do that all the time. But in transactional databases, it can be bad. Maybe bad in analytics databases too. I don't know. Denormalization, it's a thing. Yeah, exactly. Event sourcing, denormalization. Yes. All right, so select for update. Select for update is a way of telling the database that, so normally when you select a bunch of rows in the database, you are reading them and not writing them, right? So the database knows that you're about to read the data and not write the data. And read versus write is an important thing the database has to keep track of because of this contention stuff. You've got to know whether you need to lock the rows or not, basically. And the thing is that it can be common where you say, I'm going to do some work, some reads in a transaction. And then later in that same transaction, I'm going to write some data back to the same places that I read, right? Now, the database, because SQL is conversational, what that means is that as a client, you send a statement to the database, and then you can go back and do some other stuff. Then you send another statement to the database. And the database doesn't actually know what you're going to do next because it's a conversation between you and the database. And so select for update is a way of saying, hey, Mr. Database, later on in the same transaction, I'm going to be updating a bunch of rows. And you can like pre-declare this fact to the database, and it can help you with contention by pre-declaring that you're going to be updating some of the rows in the database. And that's what select for update does. Typical usage is job queue-like processing of rows. Yeah, good call. Yeah, and there's all sorts of other cool stuff you can do with this, like skip locked. So skip locked is a way of saying ignore the rows that are already locked, and you can do that. You might have some good reasons to do that for a job queue, to make sure that when you're asking for the things that are in the queue, you can skip the ones that are already being operated on. So it's less transaction contention. Select for update also helps you avoid round trips to the database. No, I don't really think so. I don't think that's the case. Is the purpose of select for update that it acquires a write lock early instead of having to upgrade a read-only lock? Yes, that's correct. That is correct. Select for update are used in stored procedures a lot as well. Outbox pattern typically does select for update and skip locked rows. Yeah, that makes sense. Skip locked for a job queue. Yeah, it makes sense. Makes sense. Yeah, these things are all related. It's about, exactly. It's about declaring what locking behavior you want to your database. Exactly. All right. Yeah, there's a lot of complexity stuff. There's more stuff that you could do here. There's like also like, I think there's something called for shared maybe. Select for share, locking reads. I don't really know what select for share does. It's something else. It's like a different type of lock. There's all sorts of crazy stuff you can do. But it's an iceberg, right? Everything in here, I feel like it's got its own little baby iceberg attached to it. Alrighty, so next up we got nulls and check constraints are truthy. This is a really weird one. So you know what a check constraint is, right, guys? So let's make a new table. Create table C. A int primary key, B int, and I can say check. And then I can specify a condition. Check B is greater than 10. All right. So what this does is it says insert into C values. Now, if I put 1 and then 1, since I've got this check constraint, this is going to fail because my check constraint says that the B value must be greater than 10. But this B value is not greater than 10, it's 1. So it says fail. Error, failed to satisfy check constraint. Okay, we continue with our lives. We can put in 11, that's gonna work fine. If I try to update, you know, it's gonna fail too, right? Update C, set B is equal to 9, where A is equal to 1, this is gonna fail to satisfy check constraint, great. So what is null about in SQL, right? Null means unknown. That's what it means. Null means unknown. We don't know what the value is when we say null. Null means unknown. So that's when, if I were to say something like this, select, 11 greater than 10, the answer is true. What about null greater than 10? Well, since null, we don't know what the value is. We don't know whether it's greater than 10 or not. So the database is going to give us back null. That's why we like to use unknown instead of saying null when we think about it in our heads. What does null mean? Because it makes it sort of intuitive to try to figure out behavior for nulls, which is sort of tricky to understand. So null, unknown is greater than 10. We don't know. It's unknown. Now, here's the question. What does a check constraint do when it sees a null? Right? What does it do? You could do different things. You could say it's going to fail. You could say it's going to succeed. Well, as it turns out, let's take a look at what it does. Insert into C values 2, null. So what did it do? It let it go through. All is well. But it's kind of weird though, right? Because that violates our intuition. If we don't know whether something satisfies a check constraint, maybe we shouldn't let it satisfy the check constraint. But SQL makes us say that it does satisfy the check constraint. So that's kind of a little bit of a weird thing called nulls and check constraints are truthy. All right. What about ascending key problem? So ascending key problem is kind of a fun one. Ascending key problem, let's say we have a new table, create table D, and we're going to say A, timestamp, primary key, and then B string, and it's a bunch of data, right? And let's say this is actually a table that we're using to write into based on an event. We're making an event table, right? And we're having some high throughput operation in our application. A high throughput application, it's writing a ton of data to this table, and it's constantly always pushing up the value of this timestamp. It's like always getting greater and greater and greater. So we're always writing to the end of the table, basically. So this is called the ascending key problem for various reasons. Why is it a problem? We don't know yet. But the reason is that when you have a table that is very hot on one end and the load isn't evenly split across that table, and you're in a distributed system, what you end up is with hotspots, because what's happening is at the end of that table is always the hot end. It's always getting hit. You're constantly inserting into it. You're constantly reading from it. And it's like a lot more active than the other parts. And that means that the system's not going to be able to effectively distribute that load that you're sending to the database. And that means that you're going to have a scalability problem, right? You have a scalable distributed database, but your application's always writing to the end of this table, which it's going to give you a problem, a bottleneck. So this is why we call it the ascending key problem. And there's various things that are going wrong here. There's contention at the end. There's the fact that only a single machine is able to handle the end. And there's also the fact that in a distributed database like CockroachDB, we don't make you shard your own data, right? The database is doing that for you, but it does mean that since you're always writing to the end, we're always constantly having to split up that end range of data into other ranges under the hood, and that's expensive to always be doing it in the same spot. So that's called the ascending key problem. And there's some ways of getting around it, right? You can change your primary key to not use an ascending key. That's an obvious one, right? You can use a random identifier instead of a timestamp. That's one way to do it. Or you can do a little bit of trickiness using something called a hash sharded index. So instead of having an ordered index, which is sort of the default index type in a database like CockroachDB, you can ask the database to put a hash column ahead of it. So kind of like, creeping back towards making you deal with sharding, but it's hopefully a little bit like less brutal than in other places. Hash shard indexes, CockroachDB. Let's take a look at how they do it because I don't remember the syntax. So it's actually pretty simple. So what I can do, let's take a look at what happens when I say explain select star from D where A is greater than now minus 1 minute. Okay, so that's something that we could do. 1 minute duration. Interval, what is it called? Okay. So explain select star from D where A is greater than now minus 1 minute. This is how it works in this table. We're going to do a precise scan in our primary key since we know it's ordered in that direction. That's all great. Let's make another table. Create table E. We're going to say A timestamp primary key using hash B string. All right. So for all intents and purposes, this is going to look similar. You can do all the same basic stuff with the hash index, but there's some important differences, which is that the database, it inserts an automatic prefix column, a hash column of all of the data in the key. It inserts this prefix column. And then when you have to do a query like this one, where you want all of the data between now and a minute ago, let's take a look at the E, right table. Well, it does something a little bit different. Since we have this prefix, which is this hash prefix, it's actually a hash mod prefix, we have to look through all of these different shards under the hood. You don't have to worry about this as a user, but the database does. And what it does is it says, let me actually get all of the data between now and 1 minute ago, but I'm going to do it in all of the shards that you specified. And by default, I guess there's 16 of them, but you can change that. And yeah, so that's what a hash sharded index is. And the way that it helps you with the ascending key problem is that it spreads out the load across all of those different shards without you having to think about shards, basically. So that's the idea of that ascending key problem stuff. Make sense? Across how many shards? So by default, you can do 16. It's 16, but you can edit it. The mod is 16 by default, but you can edit it. I just forget the syntax. It's like hash with buckets equals or something. Yeah, it's handy. It's very handy. And it's super handy too because it's completely transparent to the application. I think that's the coolest part about it. Application doesn't have to worry. It's all in the schema definition. I think that this is a principle that I really like about SQL is that you can choose to, you can edit the performance of your application by editing just the schema. of your database, right? You can add indexes, you can make hash sharded indexes, you can change the data types, you can add computed columns, you can add stored computed columns. You know, you can do all sorts of crazy stuff, and the application doesn't actually have to do anything. It says scan in the explain. Yeah, that's correct. So scan doesn't mean full scan, if that's what you're thinking. So if you say select explain, select star from E, it looks a little different. It says spans full scan. So scan just means, yeah, maybe that's confusing, but scan just means anytime we read data from the database, and full scan is the thing that we're worried about. The way this is telling us is it's saying check the 0th shard and then union the output of that with the first shard and union the output of that with the second shard and union that with the output of the third shard 16 times. So that's what this is telling us. All right. Sargeability. I like this one a lot. So I learned this recently. So sargeability is kind of a funny word. What's up, Metal Matza? Yeah. We're doing a deep dive. Just figured, because why not? It's kind of fun. We're doing sargeability. So sargeability, it sounds like it's kind of like a word, but sargeability is not actually a word. It's a made up word. And it stands for sarg, stands for search arg. And for whatever reason, somebody was like, okay, let's make a new word called sargeable, which means that the database can use a predicate on an index. That's all it means. It means the database can satisfy a predicate by using an index. So some obvious ones, we've been looking at lots of search predicates in the stream so far. We've been looking at this one. This is a sargeable predicate because the database knows how to convert this expression, indexed column greater than constant, into something that can be used to search an index. But the database can't always do this, right? If you had a really complicated expression, or even just one that isn't complicated but just isn't really supported, like for example, maybe like your where was our select star from C? Select star from, I'm having a lot of fake made up tables at this point. Show create table D. All right, so this one had a string, I think, right? So this one had a string, and if I wanted to say something like select star from D where B, and I can use this tilde thing, which means it's like a regex, I think. So if I said the regex is, metal.star, I take a look at the explain for this. Well, it's going to have to do a full scan, obviously, because we have no indexes on the table. But even if I add an index on this table, create index on div B, even if I add an index on this column, and I try to run this regex thing on the table, even with the index, it cannot. There's actually something kind of weird going on here. It's actually possible that we implemented a very basic regex sargeability thing. But anyway, you can imagine that, like, okay, let's actually make a better example. We'll put a dot star up front, like this. I don't know why it's doing this. This is kind of strange. It's actually using this text index and it's skipping all the nulls or something. Anyway, whatever. The point is that, like, normally if I were to say where B is equal to metal matza, this is going to be a nice sargeable predicate because the database can jump right to where B is equal to metal matza. But if I do this weird thing where I'm using a regex, it can't do that. It's got to do a scan. It's got to go looking through some stuff. And maybe it's like skipping nulls or something. It's being a little tricky, but it's not really important. So sargeable just means can use a predicate on an index. And it's kind of a funny, like, made up word, kind of a fun thing. All right, so next up we got ambiguous network errors. So ambiguous network errors is kind of a weird thing that can happen in distributed systems where in certain failure cases, we're going, baby. I just realized that this is gonna be like godlike YouTube content, you know? We can clip it up. We can use it to feed the content machine. It's kind of fun. I'm enjoying it. So thanks for the suggestion, the off-the-cuff suggestion 2 hours ago. All right, so ambiguous network errors. Distributed systems can fail, and sometimes they fail in a way that you don't know whether something succeeded or not. And when that happens, the database can return back to you an error that says, well, I know that I know that you committed and like I'm still alive as a database, but I'm actually not sure whether that commit really went through or not, and I can't tell you. So you're gonna have to go and check for yourself. And this can actually happen, and it's kind of a bummer, but it's a fact. I feel like that's a moment where your face starts to sort of turn into this because you're like, shit, I have to actually go check whether my commit succeeded. Can be kind of brutal. So timestamp TZ doesn't store a time zone is a fun one too. So timestamp TZ, so timestamp TZ stands for something called timestamp with time zone, right? So I can say something like select now timestamp with time zone. This is a valid thing to say in SQL. And this gives me back something called a timestamp with time zone. And I can say select PG type of on this thing to confirm that in fact it is a timestamp with time zone. Now, the really bonkers thing about timestamp with time zone, though, is that it doesn't actually contain a time zone inside of the the value, even though it says that it has a timestamp with a time zone. All timestamp with time zone does in Postgres, I think some databases may differ. All this thing does is it actually interprets the timestamp with the time zone that's set in the session. All right. So if I were to say set time zone is equal to EST and then select this again, I get a different value than I did over here. Over here, I got a +00 value. Down here, I got a -05 value, and it's because by default, we're in UTC. Down here, it's in EST, and yeah, it's very bizarre. So even if I store this value, let's do an example. Create table Z, A timestamp TZ, insert into Z values now. Select star from Z. So I have this -5 thing. If I say set time zone is equal to UTC and then select again, I get a different thing. And that's because this thing doesn't actually store the time zone inside of it. It's a misnomer. It's very confusing. What's up, Porridge? And Zapak, hello to you as well. Set that. We got star schemas. All right, star schemas, it's another analytics thing. Star schemas is also about dimensions and facts. You can say, how does it work? You have a giant table containing all of your facts, I think is the way it works. And I think I have that right. And it's a huge table with a lot of attributes. And to try to decode the attributes, you have to go to another table, which contains extra information about each attribute value, basically. I think that's how it is. And it's called a star schema because there's a big central table that has lots of tables that relate to it, like in a star. Fact in the middle, dimensions hanging off. That makes sense. MySQL having bizarre time zone issues. Yeah, I can imagine it. So that's what a star schema is. It looks like a star. All right, so here's one that I actually don't understand, you guys, because I'm not a MySQL guy. I think this is a MySQL troll meme that someone told me to add. UTF-8 MB4. A lot of people were upset by this. I posted this tweet, and a lot of people were like, oh God, UTF-8 MB4. I think it's a text encoding. I think it stands for UTF-8 multi-byte 4. I don't actually know why people hate this thing. I have no idea. Maybe it's like this. What is the difference between UTF-8 MB4 and UTF-8 in MySQL? UTF-8 is a variable length encoding. But UTF-8, aka UTF-8 MB3, only stores a maximum of 3 bytes per code point. I see. So basically UTF-8 itself is sort of hobbled in MySQL, and you have to use UTF-8 MB4. Okay. That's kind of weird. Whatever. UTF-8 MB4, there you go. All right, we're getting deep now, guys. We're in the final part of the actual ice of the iceberg. We made it through this guy, and now we've sort of ascended into a new level, right? We were just getting more and more depressed, but now something new's happening. All right, so we were leaning forward before, we were leaning up here. We were happy. We were happy once. Now we've sat back up. We've sat back up. We're straight up and down. Our hair has grown even longer. And our eyes have started to glow. Our eyes have started to glow. We're really becoming enlightened. We're becoming enlightened. We've become a Dark Souls boss. Our hair is going everywhere. We've continued to grow in size a little bit, but maybe it's more like we've got a cape now. And we're sitting straight up because we're becoming enlightened. So let's take a look. Cost models don't reflect reality. So we've been talking on and on about how great the optimizer is, right? We're like, oh man, the optimizer is so great. It knows how to pick the most efficient plan. But no, this is all a myth. It's a mystery. It's a myth and it's a lie, because the truth is that even though we have a lot of information in our memo, and the way that the database works is it costs each of the subplans, right? And it's picking the one with the lowest cost. The truth is that these costs are made up. They're just, it's like Plato in the cave, you know? They're just shadows of reality. The map does not reflect the territory. And the truth is that the cost model is a made up thing that does not really reflect the actual cost of the operations in the database, which can lead to problems. And so I think it's a sad realization once you realize that cost models do not reflect reality. You're like, damn, life is not great. Everything's a guesstimate. Exactly. Now there's sort of a flip side to this, which is that even though our cost models don't reflect reality and the database needs to understand table statistics in order to do its job, there's sort of a nice thing where it can be slow. Like let's say we have a huge table with 10 billion rows and we wanted to count up the number of rows in it. So we can say select star from A, right? And here's a small table, but you can imagine a big one. It actually has to read all the data in the database, right? To figure out the answer. Now, if you just want a short, quick estimate, you can reach down and use the database's own statistics to understand what the likelihood of the table's size is. And you can do that with explain. And if I do an explain select count star from A, what have I got here? I've got estimated row count. I've got estimated row count right here, and it tells me what the answer is. And now this case, it's 5, and that's accurate, but it doesn't always going to be accurate because statistics don't stay consistent up to date with the data in the database. It's just an estimation, but it's kind of a cool thing. Okay, Elixir Bytes. Well, thanks for hopping on and saying hi and hanging out. I'll put this on YouTube, so you can catch up with the rest of it later. But I appreciate you tuning in. Thanks for saying hi. So that's what this is about. We can use our statistics to approximate select count star. Kind of cool. All right, what about this guy? This is sort of where this is like PHP mode. You guys know like PHP is a fractal of bad design or whatever, right? That's a classic article. PHP has weird types. It's got all sorts of problems, right? Like the typings don't work. Well, unfortunately for everybody, SQL has the same kinds of issues. It's got the same kinds of issues, right? It's got selects. So I can have things like in JSON B, right? So SQL has a default native JSON type. I can say select, I can make a JSON thing like 1 points to foo in JSON. Which is kind of cool. There's all sorts of JSON operators. It's also awesome and fun. But there's a weird thing, which is that, JSON also has null, right? And I can like grab this null out like this, right? And now I've got a null, okay? So what is this? Is this a SQL null? What is this? What is this? This is a SQL null. But if I were to just say select null JSON and then compare this to null, I get false. Is that so bad? Maybe it's not so bad. Null bitmap saying it's not so bad. It's not terrible because we know this is a JSON type null and SQL type null might be different. I still think it's pretty bad. If you don't understand what's going on here, I think it could be kind of sad for you. But maybe it's not so bad. I do think that this is inconsistent, right? If I say this, if I say this, and this gives me back a SQL null, but this gives me back a JSON null, I think it kind of sucks. I'm array indexing it. Oh, yeah? All right, dude. You're very right. You're in fact correct. This makes no sense. So this returns SQL null because there's no zeroth array element. Whereas I guess if I said something like this, I don't know, man. I still think it's pretty bad. I still think this is actually pretty bad. But, you know, I guess it's not PHP level bad. No offense to PHP devs out there. Look, I don't have anything against PHP, actually. I think that if you're productive in PHP and you're doing good things, I don't like when people just like hate on stuff for no reason that makes people productive. That's not what I'm saying. Just to be clear. I'm just referencing something where people complain about PHP typing. How else do you distinguish getting a null from a non-existing key? I don't know. It's a good point. I still think this is janky. Nan, Batman. Couldn't afford it. JSON defend. I mean, I know why you're JSON defender. It's because you implemented JSON in CockroachDB. Is that part of the reason why? A little defensive? Just kidding. We were just implementing the spec. But I get it. I'm also proud of the code that I wrote. I'm also proud of the code that I wrote in life in general. We'll get to that in a second, actually. I have a little something about that. So let's take a look at some next level ones, right? So we got deferrable, initially immediate. I think this is one of the grossest things of all time. If you read this, like, I feel like it's impossible to understand what this means, just out of context. Deferrable, initially immediate. So I'll tell you what this means, but I don't think that this makes any sense outside of somebody who understands SQL. So deferrable, initially immediate is about when we're going back to triggers and foreign key cascades. That's what this is about. So in foreign key cascades and in triggers, you can choose when to activate the action, right? So in cascades, the action is like either, you know, deleting everything or setting it to null, right? And you can choose in the database whether to have those actions happen at the beginning. How does it work? You can choose to whether they happen at the end of a statement or versus at the end of a transaction. So you can choose to say only do the cascade actions at the end of the transaction, or you can choose to say do the actions at the end of the statement. And this is called the deferrability, I think, of the constraint, maybe. And you can actually specify this value on the constraint itself. So it's not like a runtime thing, it's like a schema time thing. And you can say, this constraint is going to be deferrable in a certain way. And I think what it says, what initially immediate means is that it by default is going to happen at the statement time and not the transaction time. But now that I say that out loud, I feel like I have it wrong. Deferrable initially immediate. And this is, of course, as opposed to deferrable initially deferred. So initially immediate means that this foreign key, right? Okay, so I did get it right. Initially immediate means that the foreign key by default is going to happen at the statement time and not the transaction time. Whereas the initially deferred part, it's going to happen at the transaction commit time. That being said, you can override it at any given statement, I think. Maybe. I don't know. I don't know why they have this stuff, man. It's like, yeah, so you can do it inside of a transaction. You can say set constraints deferred. And I think maybe you can also do it at the transaction scope. So like begin constraints deferred or something. Anyway, these are things you learn. Are they important? I don't know. Let's talk about another foreign key thing. Match partial foreign keys. All right, so this is another crazy one. So foreign keys in databases, right? We know about foreign keys. Create table X, A int primary key, B int. Create table Y, A int primary key references X of A, right? So what this does is it sets up a foreign key so that if I insert into X, if I insert into A, if I insert into Y and there's no A value that matches in table X, then it's not going to work. It's going to say foreign key violation. All right. Now the question is, what happens when there's nulls in the foreign key? That's what this match partial stuff is all about. But By default, I actually don't really remember what the default thing is. What happens if you have a null in a foreign key normally? Let's try it out. Insert into X values. Actually, we're going to say insert into Y values null. What happens here? Okay, well, that's because, let's try this again. Drop table Y, let's make sure it's not a primary key. Drop table Y, create table Y, a int, no primary key references. Okay, so insert null, so this works fine. So the way that it works is that in SQL, if you have a null in a foreign key value, it allows you to do it even if there's no matching null on the other side. I don't think that this makes any sense because null is supposed to mean unknown. And if it's unknown whether there's a foreign key on the other side, you shouldn't be allowed to do it because it might be false that there's a one on the other side. But such is life, that is what we're supposed to do in SQL. What's up, Emilius? It's all about practice. Practice, practice, practice. That's all. Pick your projects, work on them, and you'll get better over time. Okay, so the question is, what happens when we are going to do a cascade action that has a multi-column foreign key? That's what this is about, I think. Actually, like, don't really know. Let's drop table Y. We're going to try again. We're going to say create table Y, a int, b int, foreign key a comma b references x of a and b. There's no unique constraint matching given keys for reference table x, right? So they need to be unique on both sides. We'll say create index on x of b, like so. Oh yeah, there needs to be a unique constraint on all of them. So I need to say create unique index on x of a comma b, and then I can do this, right? So the question is, what happens when you delete? What is the question about this? I don't even really remember. I think the idea is like this. Okay, watch this. Insert into Y values 1 comma null. So this is going to fail. This is going to succeed. I think that the match partialness is about whether this should succeed or not. I think if I were to drop table Y and then create table Y and then make the foreign key match full, all right, then when I do this insert, this is going to fail because the match full does not allow mixing of null and non-null key values. And match partial has some other strange behavior. Match partial foreign key. What the heck does it do? Match full says everything must fully match or all columns must be null. Match simple is the default. If one thing is null, the constraint is ignored. And then if one thing is null, the fact that not everything null is partially salvaged by doing something sensible for the purpose of the constraint. Okay, so like you could say, you know, I don't know. Match partial, I would say, is like a confusing thing that belongs down here in the like enlightened man area. Why would you use this? I don't know. All right, so let's go through these last couple in the enlightened man area. We got TPCC required wait times. TPCC requires wait times is about the fact that, so what is TPCC? It's a benchmark for databases that simulates a workload that does a bunch of transactions, does a bunch of stuff. It's quite complicated. If you like think about TPCC and you read about it, you're like, okay, well, it's basically just a workload that does a bunch of stuff. I'm just going to implement it by having a generator send the transactions that are inside of TPCC over and over again as fast as I possibly can. And then I can measure how fast the database is as a result. And that seems like a sensible thing to think, but it's not actually what TPCC really is about. TPCC has a weird set of behaviors where in order for it to be like actually what you're measuring, you actually have to set up wait times in between each of the transactions according to a particular spec. So you've got to like wait several seconds per like actor between doing the transactions in the workload. And there has to be sort of like a fixed relationship between the number of actors and the number, the size of the benchmark. And the reason that this is important is that it removes something called coordinated omission, which is an anomaly that you get when benchmarking things where if you have a closed loop benchmark where you have a bunch of threads and they're doing things as fast as they possibly can, if the thing that you're testing starts to slow down, then so will your workload. And so you kind of give the thing that you're testing a break. It gives you back pressure. Whereas if you put wait times and you have a fixed size set of connections that you're testing, which is what you should be doing for TPCC, the database might, or the thing under test might sort of start to slow down, and it's going to get worse and worse. And that's more realistic in terms of like actual behavior. It's more realistic in terms of actual behavior. So that's why TPCC requires wait times. It's a subtle thing. Who learns about this stuff? I don't know. Only guys with red eyes, basically. Yes, exactly. Great reference, Ruben. This is exactly correct. Each actor, it's got to pretend that it's sitting around in between some menus or whatever. That's not really that important. The important thing is that it's a fixed amount of concurrency, and they've got to wait between doing stuff in order to make the benchmark valid. Ruben knows his TPCC. That's pretty cool. That is pretty cool. So what is causal reverse? Causal reverse is some crazy shit. Causal reverse is another anomaly, like phantom reads and right skew, except it's way harder to explain. And causal reverse is a situation in which even serializable databases can experience a kind of anomaly. And the anomaly is basically that if you have two people trying to coordinate together without talking to the database about their coordination, they're yelling to each other across the room about an order of some interactions, concurrent transactions. The database might choose to order those transactions in a particular random way that might be divorced from the actual real time that the two people coordinated in to send their messages. And so causal reverse is a piece of terminology that means the order that you expected is not the order that you got. And this can happen even in a serializable database. In a linearizable database, this does not happen. And the reason for why that is the case is that you can pass in a token. You can pass in a token that helps the system under test sequence the operations in the mode that you'd expect. This is the difference between serializability and strict serializability. Okay, so maybe it's not to do with linearizability then. And linearizability is some other thing. Like I said, I don't really know this stuff either. I'm a poser. But I kind of know how the words fit together and not all the details is kind of how it is in my head. So causal reverse is a weird thing that can happen. It is confusing. If you want to learn more about this stuff, yeah, so there's obviously Afear's blog, Kyle Kingsbury's blog is really great for this. And there's also something called Hermitage database, which is a nice little convenient chart that explains some of this. Well, is this really that useful? I don't know. I think this is a nice repo that has a bunch of like relevant references, and you can kind of jump from this. You can learn the defaults for a bunch of different databases. It explains some things. It tells you what the anomalies are. There's a lot of literature here, and it's not clear like how important all of this is to understand, but you know, it's just about the iceberg going really quite deep. So causal reverse is a thing. All right, we're getting towards the bottom, guys. What's up, Nikon? It will be on YouTube. It will be on YouTube. I'm going to post this one to YouTube quickly. Martin Klebman and Space Jam contributed. Yeah, that makes sense. That tracks. So our man, you know, he started pretty happy. He was chilling. Happy with the fact that SQL is a simple thing. Just a few statements to learn. Nothing complicated. And then as we've sunk deeper and deeper into the iceberg, our man has his happy chest forward expression has gone down. His hair has gotten weird. He's gained weight. He's grown ugly facial hair. He's gotten enlightened. And then at this point, he's actually turned into a dolphin. He's turned into like a creepy dolphin. I don't really know what this is about. I would say that the angle of this guy is sort of like this, you know? So it's actually a good thing because he's gone back to confidence. But he's gotten rather creepy. And yeah, I don't really know what to say about this guy. But we're in the deep depths. We're below the iceberg at this point. So let's take a look at some of these concepts. Vectorize doesn't mean SIMD. So we were talking about people being proud of their own work. This is like a little bit of a, you know, I'm proud of my own work on this thing that we call the vectorize engine in CockroachDB. Vectorize engine in CockroachDB is a system that allows the database to be efficient by doing things on a column by column basis instead of doing things on a row by row interpreter basis, or as opposed to a JIT. There's sort of, you can JIT things, you can vectorize things. In the database literature, people call this called vectorization, and it means operating column by column. And I think it's confusing because when people often talk about vectorization, they actually mean SIMD, right? So SIMD are these, fast CPU instructions that allow you to do more than one simple operation on a bunch of data at once, right? So if you have an array of 16 integers and you want to add 2 to them, you can use a SIMD CPU instruction to do that all in one instruction. So that's what SIMD is. But vectorize doesn't mean that. You can implement vectorize with SIMD, but you don't have to. And I think that was confusing for people. But in the database literature, vectorize does not mean SIMD. Single instruction, multiple data. There you go. Single instruction, multiple data. All right. So join ordering is NP hard. This is a sad fact. So what does it mean? So what does it vectorize mean? Oh, so vectorized means it's just sort of a word for the execution model that requires splitting up a database query execution into one that operates on one column at a time. So if I wanted to add 2 numbers together, select A plus B. I guess I can show it off. It's kind of cool. Select A plus B divided by C from A. Okay. So let's take a look at the explain plan for this. Well, it doesn't look very exciting here. We've just got a render and a scan, but like we were talking about earlier, there's a special explain mode for vectorize that you can use to figure out what's actually going on. And if we deep dive under the covers here, we can see that there's more going on than just a single render. What we do is we scan the data into a batch, and then we do something called a project divide int64 int64 op. And what this does is it goes through and it divides an int64 by an int64. So it's taking B and C, it's dividing one by another, all in one batch, right? Just doing this all at once. And then it's moving on to the next one, where it says, I'm going to project a plus int64 decimal op, and that's where we're going to say we're adding together an int64 plus a decimal. Here's the int64 and here's the decimal. And so it doesn't do this for the whole table at once because that's just not really what we do for various reasons. Instead, what it's doing is it's doing it in batches, right? So columnar batches. That's another way of saying vectorize, I guess. They're sort of orthogonal, but you can combine them together. Columnar batching is saying, let's read data from the database. Let's make a big batch of columnar data, maybe 1,000 values. And we're going to do 1,000 of these first, and then 1,000 of these next, and then 1,000 of these next, and then 1,000 of these next, and going back and forth. And you can get, you can obviously add more terms to this thing. If I have a bunch of divides, then I'm going to do first this divide, then this divide, then this divide, then this plus, and this divide, then this plus. Right? Oh, and I was sort of like, why is there another plus here? And I forgot it's because some of these are computed virtual columns. So it has to like do something for that. But this is what the vectorize engine means. There's some good blog posts on that on the Cockroach Labs blog as well. Vectorized Cockroach DB. Okay. Join ordering is NP hard. So this is a sad fact about databases also. You can have a lot of joins in a query, right? You can have, if you follow the normal form doctrine all the way down to its conclusion, you're going to have a million tiny tables and you're going to be joining them all together all the time to satisfy anything. And you might have to join like 20 tables together to get a result. How does the database pick the order of the things to join in, and why is that important? Well, your joins can filter things inside. They can blow up data. They can reduce size of data. And in order to pick which order of joins to do, the database has to do something. It's got to do some algorithms to figure this out, right? And the fact is that that algorithm is an NP hard algorithm. which roughly just means that there's no efficient way to do this algorithm. And as a result, people have to do all sorts of shortcuts. You can do approximations, you can do, I think Postgres does something called a genetic algorithm to figure out the output. You can probably put machine learning onto the case. You can do all sorts of different things. But ultimately, nobody ever solves join ordering exactly above a certain number of joins in database query optimization because it would take forever. If you have to join 100 tables, may have bigger problems. That is true. It's algebraically equivalent to solving the best way to multiply matrices. I didn't know that. That's kind of a cool fact. I didn't know that. But this is the case, and it just means that it's hard to implement. If you throw a lot of joins at a database, it'll get slow to plan. Let's talk about volcano model while we're here, while we're talking about vectorized doesn't mean SIMD. Real fun is running complex join reordering algorithm on an incorrectly estimated stats. Yeah, that sounds about right. I feel like there could have been some good entries in this iceberg about what happens with stats errors and how they propagate and how everything gets much worse. I feel like we have a bunch of database engineers in the chat. It's kind of fun. Kind of fun. So the volcano model is it's kind of like an academic paper. It was the name for an academic paper that explains how a database execution engine could be implemented. Let me just double check that I'm actually getting this right. Volcano model. I think the volcano model basically just means an execution engine that uses iterators to connect together all the pieces of the plan. It's by our homie. Who knows how to pronounce this guy's name? I don't. Goats. It's by our homie the goat. Goat's graph. So, I feel like the actual fact of the volcano model is more complicated than I think it is. But when I think of volcano model, I'm really just thinking of an execution engine that uses iterators to connect the different parts of the plan. But it might be actually a lot more than that. Just taking a look at this blurb. This is called check yourself before you wreck yourself, The choose plan meta operator supports dynamic query evaluation plans that allow delaying optimization decisions till runtime. What the heck? This exchange meta operator supports intra-operator parallelism on partitioned datasets. Demand different data flow within processes and data-driven data flow between processes. Just say GOTS graph. Demand-driven data flow within processes and data-driven data flow between processes. Okay, so actually I think I sort of understand what this is saying. I think what this is saying is right join is the best join. What's up, right join is the best join? Left join or right join? Should we do a poll? Thanks for the raid, Maddie. Left join or right join? Left join or right join? Left, right. Let's see what the chat thinks. Please vote in this poll. Left join or right join? Thanks for the raid, Maddie. Putting goat's graph into Google Translate with German is how you pronounce it. The meme is on my Twitter. Do I have an exclamation point Twitter? All my homies full outer massive multi-fact tables, inner all day long. Oh my God, we got memes in the chat. Everyone's just join meming. So I think what the volcano model is. Anyway, what did you guys do on your stream? Thanks again for the raid. Maddie, what did you guys do on the stream? What happened? We're having a meme review. This is called Meme Review Day. Volcano model also talks about adaptive execution planning. Yeah, man. Volcano model, it's apparently like quite a lot. I guess like a lot of the time with these database papers, they put a catchy name like something model, and then it's really just like an implementation of a database. So it's like, it could really have anything. It could really have anything. Maddie didn't make it into the Assassin's Guild. The COD model, exactly. It's a huge meme in my chat. News of the week, and I did a faces test to see how good I am at remembering faces. Nice, nice, nice. That is cool. What path would you recommend to becoming a database engineer? I think it's the same path as just learning to become a good programmer in general. My advice is to practice your programming. You know, you can read some database books and try to start to understand them, take some classes maybe, but I think the key thing about databases is that it's just a big subject matter field that you need to learn a bunch about, but ultimately it's just code like any other code. So you can kind of learn about it just by programming. Bobby tables. We Bobby tabling. I have terrible face memory. I am like very face blind, I think. But anyway, so I just want to quickly say vertical and horizontal interoperator. Okay, demand-driven data flow within processes and data-driven data flow between processes. What this means is it says that inside of I guess it's about distributed systems. I didn't really realize. Inside of a distributed system, inside of a single node, it's going to be pull-based. It's going to be iterator-based, right? So you have a plan like this one. You're basically, the execution is going to work like this. It's going to say, okay, get me the result of this. And then this guy's going to have to say, okay, in order for that, I'm going to have to get the result of this. And then this guy's going to say, in order to compute, I'm going to have the result of this. And all the way down to the bottom. That's called iterator-based, pull-based, or as this guy calls it, demand-driven data flow. Whereas data-driven data flow, okay, we got the left is winning with 81% of the vote. That is impressive. Everyone likes the left join. I think that makes sense. Right join is gross. Left join is natural and right join is gross. Demand-driven data flow, or data-driven data flow is the other direction, right? Between processes, it's called push. It's called like, you know, I'll give you an example real quick. This SQL test data. Let's take a look at like one of these guys or something. Take a look at this big old plan. Okay, this is a gross looking one. Let's find a slightly less gross one. What about sort? What about just basic? Merge join we can try. Dis-SQL merge join. No. Give us... Okay. Here's a good one. Natural join's weird. Natural join, I don't know. Okay, so here's a distributed diagram. Each of these outer boxes is a node. It's a computer. And we're trying to compute a giant merge join. Okay, select start from grandchild, join, using, blah, blah, blah. So it's able to do a merge join because the data is sorted. And so this is the diagram of how the machines are talking to each other and what the different processes are on each of the machines. So this machine, we're doing table reader. We're reading data. We're doing a merge join, and then we're sending the results over to somewhere else, you know, whatever. It's sort of a lot of complexity here. But the point is that inside of each of the nodes, inside of a given like sort of flow or a path through the graph on one of these nodes, it's pull-based. You're doing an iterator, you're pulling. And at the end, right before you transmit to another node, like right here, you do this merge join, and then you send it to this thing called an unordered aggregator. This is going to be push-based, not pull-based. And so that's, I think, what maybe the Volcano model is saying, is that it's half pull and half push, depending on whether you're in a single node or you're talking between two different nodes. I didn't even really know that when I wrote it down. So that's what that is. All right, so just as a recap, guys, we are going through this meme. We started at the top. We were very happy at the top, right? We were this guy. So pleased. Just chilling. SQL's easy. We synced lower down, realizing more and more concepts, getting less and less happy each time. At this point, we've just transformed into a dolphin. And so like everything's terrible at this point. Everything's terrible. Let's go to the next one. Nulls are equal in distinct, but unequal in unique. I think I should have said unequal, but anyway. This one's kind of crazy, dude. Null is just like such a weird concept, right? So let's take a look. Oops. Let's take a look. Let's take a look. We want to say equal in distinct, but unequal in unique. All right. So what is that going to say? That's going to say create table A int. Let's make a 2-column table, B int. And we're going to say the B is unique. Okay, so we're going to say A int, B unique int. How do you do this? B int unique? Okay, so I'm going to insert into A values 1, 2. Great. If I were to have a second thing of the same, it's going to say duplicate key value. There's a unique constraint, whatever. So the question is, what happens when you put a null in there, right? So let's insert a second row, 1, null. So this is a unique column, which means that you shouldn't be able to have duplicates. But what happens when you put a second null column inside? Everybody's happy. There are no problems here. Nobody complains. You can have as many nulls as you want inside of this table, even though it's supposedly a unique column. So that's kind of weird, right? And our intuition is that null is supposed to mean unknown, right? So we don't know what the value of this thing is. Null is not equal to null, exactly. We don't know what null is. Null is the same as unknown. So maybe it sort of makes sense. Like we're not quite sure what this thing is, and maybe it's unique, maybe it's not. A little sketchy, I would say, but that's okay. So that's what the semantics are in SQL. That being said, let's go ahead and insert some null values into the left side as well. So insert into A values null, 3, values null, 4, okay? So let's take a look at our table again. We've got some nulls on the right, we've got some nulls on the left. Now what happens if I say select distinct? So just select distinct in SQL, it allows you to get out just the values that are not equal from a particular selection, right? So I could say select distinct A from A. This is supposed to give me all of the unique values within A. But there's something quite different. There's something quite different. Very weird behavior, because we just found out that a unique constraint says that null is not, you're allowed to have more than one null in a table, so they are unique. Whereas a distinct, they are the same. We don't get 2 null values back. And so that's just like, what does that even mean? Come on, SQL. Why are you so inconsistent? Why are you so confusing? Nobody knows. I think this is some major bullshit. This is some major bullshit. You know, if I say null is equal to null, the answer is going to be null. If I say null is not equal to null, the answer is going to be null. All right. So we don't know what the answer is. SQL doesn't tell us, but we do know that these things are kind of different in behavior. We do have something called null is null, though, and that's going to be true at least. So at least there's something like that we can do. All right. So that's what this is about. Null is nan. Null is not quite the same as nan, though. Is it? It's similar. All right. Database cracking. I'm going to be honest. I put this one in as kind of a meme because the truth is that I know that this is a thing and I know what it's related to, but I don't completely know what it's about. Database cracking is a thing in OLAP databases that helps you make certain things more efficient. I learned about it once and I don't really know what it is. I just put it in the meme because I thought it would be kind of a fun one. So let's take a look at what database cracking is, because I have no clue, basically. Database cracking. It's a pretty good name, isn't it? So database cracking is about physical reorganization of the database. Anybody understand what this is saying? I definitely don't. Maybe what it's saying is that like it's a dynamic way of moving data around based on queries or something like that. Okay, this was not a helpful slide. Let's take a look at this first link. Database indices provide a non-discriminative navigational infrastructure to localize tuples of interest. Their maintenance cost is taken during database updates. In this paper, we study the complementary approach, addressing index maintenance as part of query processing, using continuous physical reorganization, in other words, cracking, the database into manageable pieces. Okay, I think that is an absolutely ridiculous terminology for this, because like, how are you supposed to infer that that's what it means? But whatever. The motivation is that by automatically organizing data the way the users request it, we can achieve fast access and the much desired self-organized behavior. Very cool. I see. So this makes sense, right? In many database systems, you can choose the organization of your database based on, clustering indexes and stored columns and column families and stuff like that. There's different ways of doing it, but ultimately it's going to be like probably sorted or hashed. Those are kind of two other ways of just, organizing the data. But what this database cracking is saying is that rather than having to pick ahead of time, the database is going to pay attention to what the query predicates are, and it's going to edit. It's going to reorganize the data as it notices trends in the queries. That is super crazy. Definitely this is more of an OLAP style thing, more than an OLTP thing. So more for analytic databases, but it's pretty cool. Pretty cool stuff. It seems like a pretty deep area to study. Kind of like learned indexes. So learned indexes, I think, are a little different. I think learned indexes are not online, right? It's not like, I think the way that learned indexes work is that instead of trying to reorganize on the fly, it's actually reorganizing offline by using machine learning, right? It's going to pay attention to the distribution of your data and make the index better, maybe? I don't know how learned indexes work. I know that they use machine learning, but I think it's more of an offline thing than an online thing. All right, so learned indexes, it's definitely, we're in the zone of the dolphin, and the dolphin's big brain definitely understands learned indexes, but not me. Not necessarily it could help you avoid distributed transactions. That's a good point. Yeah, that's a good point. That's actually a very good point. Yeah, so I don't think that AllyDB actually, I wouldn't say that AllyDB uses learned indexes. I think AllyDB is something a little bit different. What it does is it pays attention to your query patterns and chooses whether to use column-oriented indexing or row-oriented indexing based on, I think it also does use machine learning, but I don't think that you would necessarily call that a learned index. Maybe you would, though. I actually don't know. I'm not sure whether the people who made up learned indexes would say that AllyDB uses learned indexes, or just AllyDB uses machine learning to decide whether you should store things in columnar versus row-oriented form. Does CockroachDB migrate data between regions based on usage patterns? Yes. So there's two things that CockroachDB does based on usage patterns. Well, a lot more than two, but two things that are sort of related here. One is that it pays attention to usage patterns to migrate the leaseholder of a range. So in CockroachDB, the data is split up into ranges, and each range has a consensus group, and only the leader of the consensus group is allowed to perform consistent reads for that group of data. And so if you have a consensus group that has getting a lot of reads to one particular node, the CockroachDB will notice that and move the leaseholder to where that load is happening. And then in terms of moving ranges around, which is what you're asking about, migrating data around, that's something, we have a component called the allocator. And the allocator is the thing that decides where ranges live. And the allocator also has a bunch of heuristics that I think that people are trying to reinvent how the allocator works right now, actually, at the company, because we're not entirely satisfied with its performance. But yes, the allocator would be responsible for doing stuff like that as well. But yeah, to David's point, to Dirter's point, reorganizing data based on the read time could definitely help you avoid distributed transactions by co-locating data together in ranges. So also in CockroachDB, I mentioned that ranges are distributed, are consensus groups. And because ranges are consensus groups, it means that if you do a transaction inside of a range, you can use a one-phase commit transaction. So just a one PC transaction, it's more efficient. If you have a transaction that crosses ranges, you have to use two-phase commit, which is slower, basically. So maybe you should be paying attention, moving stuff inside of ranges. There's other reasons that we can't really do that in CockroachDB, which is that ranges have to be contiguous data. We can't reorganize. We don't have anything called non-contiguous ranges, although somebody's interested in adding it, actually. Let me send this to you just because it's kind of cool. I don't really understand it. Non-contiguous ranges. I don't really understand this, but it does exist as an idea. So this is the issue about non-contiguous ranges. Maybe there's some crazy stuff we can do there. I don't really know. Can you use CockroachDB as I would in MySQL? CockroachDB doesn't support MySQL syntax, so there may be some syntactic differences, but just as a high-level concept, yes. They're similar, but they're not compatible, if that's what you're asking. But they are both relational databases, so they share a lot of capabilities. All right, so that was database cracking. That was learned indexes. Next, we got to another one that I don't know a ton about. There's something called WCOJ, or worst case optimal join. And worst case optimal join is about making it so that at a high level, the join is efficient. The join is no less efficient than some bound or something like that. I'm going to refer you to another great post by my friend Justin Jaffray for worst case optimal join. Gentle-ish introduction to worst case optimal joins. Clearly, I did not study this thing enough because I don't really know what I'm talking about. But that's what this thing means, worst case optimal join. You want to use CockroachDB as your database instead of MySQL? Hell yeah, dude. You should do it. You should use CockroachDB serverless. It's the best and easiest and quickest way to get started with CockroachDB. And yeah, you can just, and it's free, by the way. Free database. Very exciting. So head to cockroachlabs.cloud and check out that CockroachDB serverless, baby. Check it out. Considering using Cockroach and Kubernetes, yeah, you could do that. It's, I'd say, if you have to self-host CockroachDB, it's very possible. But it's a bit easier to use Cockroach Cloud. How much storage do you get for free? I think it's 10 gigs. 10 gigs free, baby. That's a lot of gigs. I would say that's a lot of gigs. Do you remember when Gmail came out and they were like, you have an entire gigabyte of free email? We're like, bro, Gmail's got nothing. We got 10 Gmails. You can have 10 Gmails if you want. 10 Gmails. It's forever, man. It's forever free. Forever free database. I am using CockroachDB on Kubernetes and it's great, but it takes a bit of my time every month for maintenance. Yeah, I can imagine that. That's why cloud is a nice thing to have because other people deal with that for you. Yeah, cockroachlabs.cloud though. Check it out. Cockroach Labs. Okay, we're in hashtag ad mode, guys. I'm sorry, but you asked for it. You asked for it. We're in cockroachlabs.cloud hashtag ad territory. We're going to log in. We're going to make a new cluster. Create cluster. All right. I can choose between serverless and dedicated. I want serverless. Oh, I'm sorry. I have it wrong. It's only 5 gigabytes free, guys. I'm sorry. I didn't get it quite right. Only 5 gigabytes free. So I can choose serverless. I can choose my cloud provider. Let's do it on Google. Let's put it in. Right now we can only put it in US East 1, I guess. So that's going to change soon. I can change a spend limit, right? So I can make sure I don't spend more than $10 a month. Or I can make sure that I don't spend any more than $0 a month, which is what I'm going to do right now because I don't want to spend anything. And I'll make my cluster name large data bank on stream, baby. Oh, it's too long. Large data bank. All right, create my free cluster. See what happens. The cockroach spins around and it's done. Wonderful. I can create a SQL user, generate and save password. Generated password, I could copy this. I can connect to it using the CockroachDB client or Python. I can do it on Linux. I can do it on Windows. I can do it on Django. I could do it on Linux. You know, I can do all sorts of crazy stuff. And it's pretty easy to go. Pretty easy to use, I think. Pretty easy to use. So I can connect to this baby and play around and then, you know, whatever. So I hope you guys try this thing out. All right, the hashtag ad is over. The hashtag ad is over, but you asked for it, so no apologies. Oh yeah, it works. Of course it works with PsychoPG2. Are you kidding me? We love PsychoPG2. We love Django. We love SQL Alchemy. We love PsychoPG. We love JavaScript. We love SQLize. We love Prisma. We love it all. We love PGX. We love PQ. So many ways to connect to the database. So many ways that we could connect. We love active record. Postgres driver would you recommend for Go? You should use PGX. PGX is the best driver for Go. Cluster creation with Silicon Fast. Do I need enterprise key for Cockroach to be self-hosted? So yeah, so we do. We have some features that are license only. It is open source in the sense that you can browse the source code, but it's not all like Apache licensed. We use something called BSL, which allows, it's basically a protection against people like Amazon coming and hosting the database and selling it. And you know, the people who spent effort making it not getting any of that sweet money. But yeah, for self-hosted, there is a license thing just for the parts that are enterprise. Like for 90% of the database, you don't need a license. It's for like multi-region features. There's a couple of little things that you need the license for. But if you use Cockroach Cloud, you don't have to worry about it. Is it hard to maintain such a huge number of clients and ORMs? The answer is yes. The answer is it's a huge pain in the ass. But it's very important, so we do it. Is the licensing expensive like Oracle? The answer is that you gotta contact sales to find out. But listen very carefully. Licenses are the past, and cloud is the future, okay? That's the message I'm sending to you right now. Just don't worry about the license thing. It's really just not that important. It's not that important. I've had weird issues with libpq when scanning array field from time to time. PQ, unable to parse array, expected. Oh. Yeah, I think that there's ways to get around that. I know what you're talking about, I think, potentially. But I think libpq, it's got some issues. Just switch to PGX, and I think those problems will go away. What's up, Stoddard? Love licenses? I think that you should love cloud more than licenses, personally. Perpetual software boxes. The biggest cost of Oracle is the damage it does to your soul. Saying a lot considering the monetary cost. The internal politics of Cockroach, why pushing the cloud offering so hard? Maybe customers are bad at maintaining their database. Yeah, the answer is basically that, like, well, why is the whole industry moving to cloud, right? That's you have to answer that question before you understand why any given company would want to be doing that. But the reason is that moving as a software provider, offering a cloud service is better for you in like all sorts of different ways in terms of like predictable revenue and reducing amounts of problems that your customers have. Like the key thing as a database provider is to think about you are the best at figuring out how to deploy the database successfully and host the workloads, right? That's the key thing. What is a database about? It's about making sure that a customer workload is going to run successfully. And as the people who made the database, you're going to be much better than anyone else at being able to make that workload successful. So that's why you provide a cloud service, because it's going to be a better offering. And there's business reasons too. Like that's a whole other factor. But like business reasons, like there's about total cost of ownership, and there's about predictable revenue, and there's all this other stuff. But why do people use cloud? Why is cloud winning? It's because of this thing where it's reducing total cost of ownership, reducing the amount of ops you have to do, reducing the amount of headache that you have to maintain a service, and changing it into, you know, paying for something on a predictable cycle versus having to figure stuff out and hire people and do stuff like that. So that's kind of the reason. Imagine on the beginning, huge blade servers. The only thing I worry about cloud offering is noisy neighbor problem. Yeah, that's a fair worry, but I don't think it's, I think noisy neighbor problem is still there. I wouldn't say it's gone away, but I don't think that you have to worry about it that much, really, these days. I don't have a great answer for that, but I feel like just thinking about like the kinds of blog posts I've read and like the complaints that people have, noisy neighbor, I feel like it's been going down over time as like a common problem. Maybe the clouds have just gotten better at preventing it. On anything debt for, can you get dedicated Cockroach V instances so that there's less noisy. Yes, you can. So you don't have to make a serverless cluster. You can also create a dedicated cluster, which is more expensive, but these are dedicated VMs that aren't shared by anybody. But of course, the cloud provider, there's hypervisors, right? And those VMs are going to be living on physical machines that might be used by other people. So you can't, without asking for truly dedicated hardware via the cloud provider, you can't actually remove that noisy neighbor problem. And I don't think that we have a way of doing that. Like, I don't think we allow you to get like a mega massive box that doesn't permit anybody else to be using the like actual backing hardware. So that's, yeah, I think you could basically still have noisy neighbor even on dedicated cloud instances, but it's definitely a reduced problem at that point versus like a serverless offering. But yeah, anyway. AWS offers dedicated physical hosts in case someone's scared. Yeah, that makes a lot of sense. What I'm trying to say is like, at least in this this incarnation of Cockroach Cloud, we have not allowed you to pass through the dedicated AWS machine option. Anyway, that's the deal. You can host it yourself however you want. You certainly could. You certainly could. And it's true. Like CockroachDB, it is very easy to deploy. It's just a single binary. You download it. You can set it up in a cluster in a matter of minutes. It's very easy to do. It's just that we're still going to do it probably better than you, not because you're bad, just because we have a lot of practice. Host it on an RPi on an SD card, place a hosted database. Okay, we're getting there. We're getting to the Halloween problem. Can you have managed Cockroach in your own cloud account VPC? No, we don't offer that right now. Okay, so let's get to the next stuff. Transaction ID exhaustion. This is a sort of Postgres specific thing that is kind of a scary thing that happens. So people like to talk about it. Transaction ID exhaustion is the fact that if you're running Postgres and you don't run vacuum a lot, this thing is called a transaction ID, and there's only 32 bits worth of transaction IDs. And if you do not run vacuum or something and you use up all of those transaction IDs, you can run into all sorts of really broken, messed up problems. So this is just a reminder, yet another reminder why you should run vacuum on your Postgres database, or else you'll run into problems like this. You got to collect the table statistics, recluster your indexes, do MVCC garbage collection, clean up the transaction IDs. Yeah, vacuum is like a maintenance command on Postgres. Not every database has something like this, but Postgres does. CockroachDB does not have vacuum, by the way. It's a Postgres thing. Yeah, you got to hoover that baby. All right. We've moved past the dolphins. We're getting there. We're getting to the final level, the full enlightenment level. As you can see, we've gained full straight up and down alignment. Our arms are perfectly balanced. We're glowing. We've gone into the sky. At this level, we're deep below the iceberg in the very, very darkest depths of the abyss, but we are truly enlightened at this moment. Let's take a look at some of these. All right, so the Halloween problem. Let's start with that, since Stoddard was asking about it. The Halloween problem is a sort of apocryphal tale that happened. An apocryphal tale that happened in the like 70s or something, where someone was like, okay, let's actually make it, well, we can make a little how do we construct the Halloween problem? Let me just describe it first, then we can think about constructing it. All right, so the Halloween problem is that some guy was like, I need to give my employees raises. All right, so back in the 70s, people were making $32,000, and everyone was like, okay, everybody below $32,000 is going to get a 10% raise, okay? That was the goal. Everybody who's making below $32,000 is going to be getting a 10% raise, okay? And so this person wrote a SQL query that said, update salaries, set salary is equal to salary plus, salary divided by 10, where salary is less than 32,000, right? We'll do an example. Create table, employee, ID int, salary int, insert into employee values 1, 17,000. Insert into values 2, employees 2, values 2 comma 40,000. All right. So I want to give everyone a 10% raise so I can say update employees set salary is equal to salary plus salary divided by 10, where salary is less than 32,000, right? Okay, so this is going to update everybody. And if we do select star from employee again, we get some output that looks pretty good. You know, we added 10% to 17,000 and we didn't touch this guy. So the Halloween problem is that this statement in a database is somewhat difficult to figure out how to execute as the database, because the data that you're updating is going to be moving around as you're updating it, right? So let's say you're updating 10,000 different salaries, and you're going to be looping through each salary looking for ones that satisfy this predicate and then updating the ones where they do satisfy the predicate. As soon as you do update that value, you're going to be writing back to the database another value, which is going to be the new salary for that employee. Okay? But if it's the case that your database implementation isn't careful, you might accidentally see the new value again lower down in the scan. Okay? Meaning, even though you've already updated this guy by 10%, since the salary is still less than 32,000 and the physical row gets relocated somewhere else, the database might rerun into that row and then keep updating the salary again over and over until the salary does not satisfy this predicate any longer. So that's the Halloween problem. It's the fact that when you, well, it's infinite until you hit this thing. But yeah, the Halloween problem says that unless you're tricky, you are not going to necessarily get a snapshot that doesn't change after you update. You know what I mean? You have to be only looking at the things before the updates happened, or else you'll get into weird problems. So that's the Halloween problem. And yeah, it's kind of a subtle thing, but it's kind of a fun one. It's got a great name. I feel like things with great names belong at the bottom of iceberg memes. So how do you solve it? Right. So it kind of can exist with cockroach, actually, believe it or not. It's just more of a subtle thing than the one that I described. And the reason is that if you're not careful, okay, so let's take an example. Let's think of how do we make an example here? Let's say you have a nested, like a common table expression that does a bunch of mutations on the inside, right? First, you're going to do some mutations here, and then you're going to do some mutations over here. What if the first set of mutations edit the values that are going to be edited again by the second set of mutations? The question is, does that second set of mutations use the original set of things before the mutation, or the ones after? Do you know what I mean? There's sort of the sequencing problem. And so in order to deal with this, like, there's different ways to deal with this. One way is to use like a sequence number, so that when you're writing things down, you make sure to write down a sequence number along with the data so that you can know whether you should be looking at the new version or the old version. There's kind of some different techniques that you can use to deal with this fact. But there's various tricky ways where the Halloween problem can creep up, and it's quite subtle. Raises have been suspended indefinitely to prevent database anomalies. Thank you for your commitment to the data security of our organization. That's awesome. I love that. All right, so that's the Halloween problem. Pretty cool one. All right, let's do all balls. All balls is nice and simple. All balls is a weird thing where if you say all balls and you cast it to a time, oops. You cast it to a date, oops. Maybe actually Postgres or Cockroach doesn't support this. Let me try it in Postgres. Select all balls, date. What? The heck? There we go. Okay, so it's only working for time. So all balls casted to time gives you back midnight. And the reason for this is that all of the zeros in the time look like balls. Supposedly this was like a military thing from JPL or something. Some guy was like, yeah, if midnight, it's all balls. And they added that, like maybe just for funsies. So that's what this means. Yeah. I don't really know what quite what to say about that one, besides the fact that it's kind of lol. But it's definitely a thing. Does it work into cockroach? I don't think it does work in cockroach. I guess we didn't implement it. It doesn't really seem that important to get right. If Athena does it, I feel like we might have like implemented it once and then like maybe deleted it or something like that. I don't know. It's one of these things that just doesn't really seem that important to get just right. All balls in Germany right now. What's up, big black dog? It is like an Easter egg, yeah. It's a little baby Easter egg for sure. Yeah, all right. So next up, we got fsync gate. So fsync gate, I don't know if this was like exactly such a clear thing, like a gate exactly, but there is such a thing called fsync gate. And fsync gate was this moment in, I think this was just basically a Postgres thing, but it's also kind of an industry-wide thing where people like don't totally understand how fsync works and like what you have to do and when do you have to fsync in order to make sure that your data is actually durable. So jumping way back up to, we talked about ACID at the top of the stream, right? We were talking about ACID, and the D in ACID is durability. And to get durability, you have to make sure that you're using fsync at the right times, because file systems are going to need you to fsync, or else they won't really durably store stuff if you do stuff like, you know, shut the power of your machine off halfway through the write, right? So you got to get fsync just right, or else you're going to have corruption problems, and they're very subtle. It's very, very subtle to understand when you're going to have a problem with fsync. So fsync gate was at this moment, I think, and let's see, let's take a look at what it says on Google. Fsync gate. There's a moment. Oh, Dan Liu wrote about it. Oh, I didn't realize that. I was looking at this one on the Postgres wiki where it says fsync gate 2018 mailing list thread. Would it be dumb to sync SQLite to cockroach? I would say probably. You can use local cockroach too pretty easily. I guess it's a process though. The problem with retrying fsync after failure, not knowing which pages are dirty and which aren't. File systems make cache, hard drives make cache. Yeah, it's quite complicated, huh? So fsync gate was, I guess, a thread, and it's not even so long ago. Postgres is handling fsync errors is unsafe and risks data loss, at least on XFS. So I guess maybe what happened was that you get an error and it didn't handle it quite right, and then everyone was like, oh God. Things are problems. Here's what Tom Lane says. So Tom Lane's like the maintainer for Postgres, right? Tom Lane says, PG should panic as fsync EIO return. Surely you jest. Retrying fsync is not okay, at least on Linux, because if it returns success, it means all right since the last fsync has disk, but we assume it means all right since the last successful fsync have hit disk. And then he says, if that's actually the case, we need to push back on this kernel brain damage. Okay, so this is like a little bit of like Linus Torvalds language, but anyway, kernel brain damage, because as you're describing it, fsync would be completely useless. Moreover, POSIX is entirely clear that if successful fsync means all preceding writes for the file have been completed, full stop, doesn't matter when they're issued. No all balls on Snowflake. The answer is that you should just crash the process if fsync ever fails. I think that's basically what Cockroach does. Any callers of fsync in the backend code are careful enough to check the return status, regression, blah, blah, blah. People are shocked. I'm speechless. Anyway, there was a gate. It was basically a gate. Everyone's upset. Everyone's upset. This is what fsync gate is about. People don't understand fsync. I guess there's a good Dan Liu article about it too. These articles are usually pretty good. Well, so in Cockroach, it's actually nice. We can crash the database very easily because it's a distributed system that has resiliency. So if we encounter things like, weird corruption or fsync problems, rather than risk letting that corruption spread to the other replicas, you can just panic the server and it'll get restarted and things will usually be okay. That's pretty cool. A great FOSDEM talk about this too. That's cool. So that's fsync gate. Sad times for the database and programming community. All right, let's go to the right-hand side. Here we have serial is not transactional. If you crash, will pending operations fail transiently? Yes. So you will potentially get an error back to the client, of course. Like, let's say, you were connected to a particular server as a gateway and that server just crashed. Your connection's going to close and you'll have to retry. And even if it's not, even if you weren't connected to a gateway that crashed, I think that your connection might return and kind of like a transient error that you'll have to retry with. Definitely true. Another reason why it's important that all of our queries have retry loops around them. In any database, you need this, but in distributed databases, it becomes a little bit more obvious that you need it. How is it possible that Postgres used fsync incorrectly for 20 years and what we'll do about it? I love that. That's awesome. 20 years. Crazy. All right, so serial is non-transactional. So serial is, I think serial is this basically a data type that allows you to use something called a sequence to auto increment values. That's the idea. So let's make an example. Create. I can't actually remember if Cockroach, I think Cockroach does something a little different with serial. Create table A serial, primary key. Using sequential values in a primary key does not perform as well. Okay, so it's doing the right thing, but it gives us a little hint. It's basically saying, like, don't do this. Try something else. Insert into a default values. Select star from A. Oh, wait. So we do actually do something weird. How do I get Cockroach to use sequence? Cockroach DB serial sequence. There's a way to, like, get it to virtual sequence. How do I have it do that? Actually, what I want is this. I want SQL sequence. How do I get it to use that? Okay, there's translation modes, but how do I like set it? Oh, I see. I feel like there's a docs issue here because it's not really explained to me how to set the mode of operation. Oh, there it is. This mode can be configured with the session variable serial normalization. Okay, so I'm going to say set serial normalization is equal to SQL sequence. Then let me recreate my table, drop table A, create table A serial primary key. Okay. Let me give it another value as well, bint. Okay, so insert into A values default, comma 2, default, comma 3, default, comma 4. So let's take a look at what we've got. Now they're truly sequential, and that seems all good. So we have this magical thing. It's giving us, incrementing values in a sequence. But there's a very weird thing that can happen, which is that, let's try something else. Let's say begin. We're going to make a transaction. We're going to say insert into A values default, comma 5. All right. So let's say select star from A to see what we have. We have this 4 and 5. Now, if I were to say abort at this point, normally what you'd expect is, okay, the transaction is going to roll back. So I select star from A and I don't have that last row. And you'd expect that if I did this again, insert into A values default, comma 5, I would get the same row back, 4, comma 5. But actually what we get is something weird. We skip 4. 5, comma 5, all right? We skipped 4, and that's very weird because this sort of means that something went weird inside of that transaction, right? Normally, inside of a transaction, you roll it back and everything goes back. It's a little haunted. And the reason for this is that these sequences that are used under the hood, so show create table A, these sequences that are used under the hood, this is me incrementing this sequence, seek. And this is a non-transactional operation, just because. just because of reasons. Just because of reasons. This is non-transactional. So if I do this inside of a transaction and I roll the transaction back, it doesn't roll back this sequence increment. So that's the reason. Kind of spooky. Kind of spooky. Serial is non-transactional. What's up, Yuji? Why SQL and why not a different DDL DML? I'm assuming that you're just a troll because of your username, so I don't know what to say about that, but I'm not going to answer. What's up literally did just this for you? We're going through a meme. Many apps depend on not reusing IDs. It's true that many apps depend on not reusing IDs, but if the transaction was aborted, then nobody was going to be using that ID, so it should be fine. The non-transactional thing is just sort of a quirk. It's kind of just an artifact. It doesn't make anything worse, or it doesn't. If it were transactional, it wouldn't have anybody reusing IDs or not. How is the property market in Brooklyn? It's brutal, dude. It is absolutely brutal. Everything's going down. I would say, when I say brutal, I would say that things are expensive. And New York City has a very unique real estate market where things, you know, don't really go down. Null is at the top, so mark that one off. Yeah. Things aren't going down enough. Exactly. That's correct. Did you like that? So I included null at the top and at the bottom because I thought that it's an accurate thing. Like you learn about null very simply, very early in your database career, but then over time you realize that, God, null is like the most complicated and annoying shit ever. Yeah, I made the meme. This is like our victory lap. We got a viral tweet out of a meme that we made, and then this is our victory lap to explain the entire thing. The deep null. Yeah, this should really be called deep null. Thanks for the 100 bits. Appreciate it. Yeah, I'm definitely gonna keep the recording. Normally it takes a while to like post these VODs and stuff, but I'm gonna post this one ASAP because you gotta feed that content machine, you know? Gotta feed the content machine. Just kidding. It's also just cool. Blorfs. Anyone else work with people who insist on coalescing everything in comparisons? Didn't mean it as a troll. Okay, sorry about that then. Why not some other language syntax, and why stick with SQL for Cockroach? That's a good question. I mean, the reason is that SQL is this like lingua franca kind of language that everybody knows, everybody understands. It's compatible with everything ever. It's quite difficult to like escape SQL, the SQL vortex. I don't know if we're going to really escape it as an industry. Lots of people have tried. You got FaunaDB, you got Datalog, you got GraphQL, but I don't know, man. I don't know when SQL is going to go away. It's not clear. Timestamps for each topic. Oh, that's a good call. That's a good idea. It's kind of high effort, but it's a good call. Thanks again for the second 100 bits. Literally did this just for you. Where coalesce? I guess it's just to get rid of the nulls, but yeah, I don't know. Is that a best practice? It's funny, like I do a lot of database programming, but I do not do a lot of database SQL query writing, which is a little bit awkward, but it's facts. Is it best practices to use coalesce everywhere? I don't know. Yes, it does. No, it definitely matters for both. Yeah, the VOD is on Twitch and it'll be on YouTube as well. So subscribe to my YouTube. But it'll also be on Twitch. The only thing is that the VODs only last on Twitch for like a couple of months. If you say null is equal to, 3, you're going to get null back. All right. So let's take a look at D and dumb. D and dumb is another one that, like, I don't know. I think it's kind of a troll because you put it at the bottom because it's got a funny name. I don't know. Is this such a deep concept? I don't know. Do I understand what it is? Like, only vaguely. Lucas Eater. You guys know Lucas Eater? He's a guy who made Juke. Wonderful fellow. Great follow on Twitter. You should definitely follow Lucas on Twitter. But he taught me about this dumb and D thing. And it's just, I don't know. You can't resist putting something like dumb and D at the very bottom of your iceberg because it's like, they've got some funny names. Speaking of nulls, how would you deal with ordering on nullable columns when using cursor-based pagination? So that's a good question. That's actually something that I almost included, but you can put nullable, you can choose to put nullable columns at the end or the beginning of your table. Actually, I don't think this is a big deal. I don't actually think it's a big deal because regardless of what you choose, you don't have to choose anything. By default, the nulls are either going to go all the way to the top of an index or all the way to the bottom of the index. And they don't get like interleaved if you have an indexed column. And if you're doing cursor-based pagination and you're doing it on a particular index, then the nulls are going to be all the way at the top or all the way at the bottom. I assume he was actually talking about key set pagination, not cursor pagination, but it doesn't really matter. Either way, it's the same answer holds for both. We don't really like cursor pagination because it holds open resources on the database side. So D and dumb, they're kind of like these sort of weird tables that, dumb is a table that has no columns in one row or something, and D is okay, actually there's sort of a, do you guys remember Everything 2? I think there's a good Everything 2 article on this stuff. I feel like Everything 2, isn't this called Everything 2? What is this thing called? C2. Maybe C2 is not the same as Everything 2. Anyway, I think this is a very cool, weird website that is old school. There's a lot of weird commentary on it. It's a very different form of web that nobody really does anymore. But like, take a look. You like click through this. You have people like Ward Cunningham just like commenting on this article kind of, and the way that you comment on this article is you just edit it. You just put it at the bottom. It's like a big wiki, but it had seemingly a very special culture. And these things don't get updated anymore. But anyway, so dumb and D. Dumb is the relation that has no attributes and no tuples. It plays the role of false. And table D is no attributes in a single tuple. So we can simulate this. We were doing this earlier with dual. We can say create table dumb. No attributes and no tuples. So we have dumb. Select star from dumb. No attributes, no tuples. We can create table D. Create table D. Create table D is supposed to be no attributes and a single tuple. Insert into D default values. Select star from D. Spooky. Very spooky. Select star from D. Cross join D and dumb. What happens? You got nothing back. Very spooky. Anyway, what's the point of this? I don't know. What is the point of any of this? It's not very clear. Not very clear. But it's kind of a fun little artifact that lives on C2. Key set. Yeah, key set pagination. All right, so we're getting to the end, guys. Every SQL operator is actually a join. So this one's also a little bit of a troll. This is like the troll section, I guess. The troll depth. Here's yet another one that I'm going to refer to my friend Justin. He wrote a good article called Join, the Ultimate Projection. Join the Ultimate Projection is an article that explains how joins are sort of a special core operator. I wish that I could paraphrase this article. Justin's a smart guy. He's smarter than me for sure. But the summary of this article is that you can use joins to do anything. That's the way that I took it anyway. And so I kind of, this is not really the case that every SQL operator is actually a join, but you can kind of play around, and joins are powerful and they're kind of foundational. You can do projections with them. You can do all sorts of stuff with them. Maybe you can actually secretly do aggregates with them too. Maybe, if you try really hard. Use joins to generate a fractal. Every SQL operator is actually a join. This is the proof of this is left in the margins of this meme. No, sorry, it was too large to fit in the margins of this meme. So you guys are gonna have to figure that out for yourself. We got null. The final level. All right, so now you guys are all SQL experts, huh? We did it. You guys are SQL experts. Congratulations, you've passed the course, and you can be admitted to SQL grad school. What's order by? Order by lets you sort data. Is that what you're asking? Oh. I just, I don't know. I just thought I'd answer it seriously, just in case. You never want to make fun of people for not knowing stuff, so. Now we just need to forget it all so we can all be as happy as this guy. Yeah, this guy's so happy. We all want to be this guy. This guy could have a better hairstyle, though. Yeah, I think that this guy should become an emote in our chat. Don't you think? I feel like this guy should become an emote in our chat. What's a good emote name for him? SQL Sam. He kind of is friends with this guy. This is the genius, and this guy's name is we have Jordan Pog. Only data scientists are that happy. I like SQL Sam. Large D2 SQL Sam. Oh yeah, you took the screenshot. I don't know how do you give a credit for I actually think that there's a way to do that. Peter Gibbons? I actually don't remember how to do I'm like afraid to click around in this. What if it exposes me? Is it stream settings? Anyway, whatever. I'll do this later. Oh, emotes. Here we go. I thought there was some kind of... Anyway, whatever. This is like extremely unimportant. Name your new emoji zero cost. So what do you guys think? What's the next meme? What's the next meme that we should do? Large D2 null. Large D2 SQL Sam. I like this guy being named SQL Sam. I like this guy being SQL Sam. Anyone know how to use Figma? How do I cut this thing out? Okay, I have an idea. We're gonna copy this. We're going to bring it to remove.bg. Boom. Let's go, dude. Let's go. Was that keyboard made from a kit? I actually bought it from... the company that makes these things, which is called keeb.io. So I didn't make it myself, but I guess they made it for me. Performance meme. The tier list thing. Yeah, so I don't really like, I think it would be kind of funny to do a database tier list, but it also like gets a little bit too close into like competitive analysis of databases, which I don't do. That's actually, you guys should all join my Discord, but that's a rule on the Discord, which is that we don't do competitive analysis of databases on the Discord because it isn't really all that fun. It's a little bit like negative, you know? So we don't, I wouldn't really want to do something like that on the stream, I don't think. But I think we could do features. We could rank SQL features. That would be pretty funny. SQL feature ranking. A performance meme. Null is in the null tier. That's actually pretty funny. I like that. Distributed database features. I do want to do one. I was talking earlier. I want to do one about people. So there's an argument about somebody just asked about it, right? The guy with the funny name was asking about why SQL and not another query language. I feel like the argument between SQL and non-SQL would be a great fit for this. This wasn't my original idea, by the way. It's my friend's idea. But anyway, this, you know, the meme where American chopper argue meme. I feel like this would be a good meme to talk about people arguing about SQL versus non-SQL. It would be pretty good. Use joins to generate a fractal. Wait, what? That's an old comment. Why did that just pop up again? I just want to add this emote. Emotes. There's some startup that creates infrastructure code through SQL. That's kind of hilarious. Like a Terraform via SQL or something. Image is not square shaped. Okay, I need to make it square, I guess. Okay, guess this is not the tool to do it. How do I crop this baby? Resize. No. Does this thing have an editor or not really? Ask for an interview at this thing? Paint 3D. Should we just squish him? I feel like we shouldn't just squish him. How do I crop? How do I crop? Crop. Okay, first we crop just so. Just so. And then we can squish him a tiny bit. Does he look the same? No, I think he's better tall, don't you think? I feel like he's better tall. Add more space on the left or right. Okay, that's a good idea. How do I do that? Select all. Crop. Add more. I can't add more. Maybe I should just crop him. Crop. Done. Okay, this is good enough. Save. Okay, so the name is going to be, I like SQL Sam. I like SQL Sam. All right, it says it's done. Large D2 SQL Sam. Maybe I have to like refresh chat though. Okay, I'm refreshing chat. Dude, what the heck? It said it was gonna be instant. It's not instant. It's some bullshit. Let's give it some time. Let's give it some time. Yeah, these are some super eventually consistent shits. That's for sure. I did refresh the page. What if I go over here and do it? Very not acid. The heck? I guess we just gotta give it time. Very disappointing. Very disappointing. Anyway. Good stuff though. Twitch is a small indie company. We can't expect too much. Yeah, dude. Just a tiny little baby company. Absolutely true. Absolutely true. Fsync Twitchgate. Dude, I just want SQL Sam. I just want SQL Sam in the chat. It's not too much to ask. It really is not too much to ask. It seems like a simple, basic ask. Maybe you can't, can you not edit them like during a stream or something? He's there. He's there. He's there on my screen. Let's go. SQL Sam. Let's make it happen. There you go. He's not, I would say that he's a little bit hard to see. He might need like a background or something. Or maybe we should just zoom in on his little head. It's because you're not a sub. It's a sub emote. He needs edge lighting. Yeah, you're probably right. That's right, baby. It's pay to play. Pay to play for SQL Sam. There you go. Thanks for the prime. Thank you for the prime. And Unafraid BG, thank you so much for the tier 1 sub as well. Now you have the best library of SQL specific emotes in all of Twitch. On all of Twitch. Thank you, Sergivos, for the tier 1 sub as well. Bro, Unafraid just going wild. Buck wild with the gift subs. Thank you for the gift subs to UTF-4, Ashtakor, Coder, Laman, and Applied Chain. That's very nice. Thank you. UTF-4 is a homie, huh? Zapak, thank you for the tier 1 sub. You guys watch UTF-4's, yeah, Moneymaker Sam, honestly. Sam just netted me all those subs. Love that guy. What a buddy. You guys watch UTF-4 stream? Love that guy. Great stream. Great stream. I think UTF-4 was instrumental into me starting to do coding streaming. So shout out to that guy. I think there might be 2 of them actually, but shout out to that stream anyway. Thanks for all the subs, you guys. Very generous. Appreciate that. So, what should we do? All has read? What's all has read? I don't think so. I don't think I know what all has read is. Security researcher? I don't know anything about security stuff, you guys. Somebody, you should get them to make a security iceberg. Because, like, bro, I know Jack about security. Jack. I know, like, there's... Yeah. I don't know anything about it. People are using, like, those disassemblers and searching for weird exploits and stuff like this. Like, I don't know. It's just a different world. It's a completely different world. Another crazy world is like, yeah, SQL injection's definitely the top level. It's like it's like the baby level. Cross-site, you know, XSS or whatever, that's the top level. There's so much crazy stuff in security world. Another crazy world is networking. I interviewed somebody who was doing networking stuff. They worked on this. What is it called? Like a level 3 load balancer, level 4 load balancer, one of these like lower level load balancers that just like routes raw TCP. Is it TCP or is it the one right below? I can't really remember. Anyway, they were working on some kind of crazy load balancer thing that happens at some low level. And I was just like struggling to figure out what the heck they were talking about. You know, this purpose of this interview that I do is to like, you ask them about a project that they worked on and you try to ask them intelligent questions and see the way that they think about things and ask them about testing and ask them about architecture and stuff like this. But I was like just barely holding on to what they were talking about, because I guess implementing one of these things just takes a lot of specific knowledge about networks that I just don't really have. Maglev, that's the name of this. Like they Google Maglev Google. There's something called Maglev at Google. They didn't work on Maglev, but they worked on something similar to Maglev. Network load balancer. Equal cost multipath. I don't know. This shit's crazy, dude. Absolutely bonkers crazy. Please do not throw sausage pizza away. Oh, that's nice. That's a good little acronym to remember. Physical data network transport session presentation application. There you go. That's something that I do not remember. But yeah, man, this stuff's complicated. Packet rewriters. Steering. Muxing. VIP matching. Like, terms, man. Consistent hashing. You got everything. VIP announcer. Health check. BP. Config manager. Config objects. It's crazy. You guys ever heard of Computers, they're complicated. Blog post about their 80 gigabit machines, and by the end it was over your head. Yeah, there's a lot of things that go over my head, man. Computer science is a big and crazy world full of complicated stuff. Hype train, baby. Thank you for the hype train, guys. Hype evil. Scam train, right? Talking about the scam train. We are talking about scams and hypes. $800 gigabit and beyond, baby. Disrupt videos on YouTube? I'm not sure. What is that? I'm gonna get some water, guys. I'm gonna be right back. Disrupt is a channel they do to easy to watch docs and hackers. Okay. Hackers. Love hackers. Yeah, I don't know. It's a whole world. It's a whole world of craziness. Hard to get into, I feel like. Wow, this took a lot longer than I expected. We're almost at 4 hours, and all we did was go over the iceberg. I'm not sure what to make of that, but I don't know. I feel like I don't really want to do programming right now. I feel like I'm kind of already a bit tired from going through this freaking crazy iceberg, but that's okay. I didn't really have a good project in mind for this week anyway, to be perfectly honest. I was going to maybe look at this thing. It's actually, I think this somebody from the Hasura people filed this. Just a little issue in Cockroach. Thought we could fix it, but whatever. I don't know. I'm a little tired, I think, to do that right now. But this was fun. This is actually really fun. Memeing on stream. We're talking about stream memes. We're talking about meme streams. Quite fun. Really fun to go through and explain all this stuff to you guys. And I think it would be really fun to do one of these live on stream as well. When is the next Cockroach release? It should be in a couple months. Variety streamer? Yeah, basically. This should be just chatting. This is a just chatting kind of stream for sure. Playing Fortnite next? Cool. Metal Matza, thanks for stopping by and hanging out so late. Have a great night. Tried using TTL and it needs to be a table without FKs. Yeah, that is true. Is that a big problem for you? Wow, that's a major compliment, Rohan. I don't think this thing is anywhere near the level of Julia Evans zines, but thank you for that. That's nice. Nice compliment. Her shit is next level, dude. Her shit is absolutely next level. People, yeah, I think she's like a unique talent for sure. Just fit nicely on this one table, but not really a problem. What's everyone got going on this weekend? What's everyone got going on this weekend? I'm playing tennis tomorrow. I'm excited about that. Quite excited. Hit some balls, baby. Try to get him over the net. Rust, Kubernetes, database work. What's up, Danderfluff? Wedding for your ex-roommate? That's nice. Congrats to your ex-roommate. All balls. I had a roommate in college, my first roommate, freshman year roommate, who, like, we were only roommates for that 1 year, so we would go around, we were still friends, and I would be like, oh yeah, this is my friend, my ex-roommate. And he would always look right at me, and he'd look right at me, and he would be like, former roommate, never say we're exes, which I thought was kind of funny. Every time somebody says ex-roommate, I think of that guy. Former roommate. Rewatching the video to grasp the iceberg. Nice, nice, nice. I hope it helps. I hope it helps. Yeah, I guess I'll put this up on YouTube ASAP then. See if people will be interested in watching it. Do I also watch or follow tennis? Not really, not really. I'm a beginner. I'm just getting into tennis at this moment. I played in high school. Played it when I was younger, but then I didn't play for like 15 plus years. So I'm pretty much just beginner level garbage, just trying to get back into it because it's a very satisfying, fun sport, but I'm terrible. It takes a lot of time. It's not something that you can just pick up really. You gotta take lessons. You gotta practice. You gotta do a lot of playing before you're competent. But yeah. You slipped on a cord and had to get a root canal, but you won the point. Worth it? Definitely worth it, I would say. 100% worth it. Sounds like a racket to me. Yo. Damn. People are just memeing up a storm. All right, y'all. I think it's time to sign off. I think it's time to sign off. I'm gonna play some tennis tomorrow. Try to enjoy the weekend. And then I'll be back next week though. We'll be back next week. Let's go ahead and find someone to raid. Go ahead and find someone to raid. It's been very real. Thanks for all of the fun, engagement, chatting, subs. It's been fun, really fun to explain this meme for 4 hours. A good time was had by all. Next week, are you going to Burning Man? You going to Burning Man? My sister-in-law is going to Burning Man. All the best memes take 4 hours to explain. Nice. Well, maybe you'll run into my sister-in-law. Who knows? Let's see here. Who should we raid? Tech version of Reddit review. That's true. 70K people. See you later. Thanks again, guys. Thanks for stopping in. It's been real. Let's hope to see you next time. I feel like we could either raid. We did Coding Garden last time. We could raid Andrew, the Zig guy, or we could maybe. What about Luke Pighetti? Let's raid this guy. I've never seen this guy before. Luke Pighetti. This will be good. This will be good. All right, y'all. Join the Discord. Join the Discord. Sub to the YouTube. See you guys next week. Bye-bye.